Okay, perfect. The stream is on. So we're gonna continue our password generation project that we have made lately. So yeah, actually I have changed my operation system. So for that reason, I'm just gonna go to my channel and just try to recover that script that I have written lastly in this live stream. So I'm just gonna go over this. Okay, so this is a generic code that I could find in the project pre-installed, but all of this is gone. So I'm just gonna try to recover it. And after I do that, I'm just gonna go and compare it to the code of Angelina, which is the teacher of this course. Okay, so I'm gonna go to here, day 4 or day 5. Okay, yes, so it's day 5. Okay, let me just make a better quality for HD. Oh, this is way better. We're gonna go to PyCharm, day 5, then password generator project, then there we go. Let's get these things off. Okay, perfect. So so we have all of these codes ready. We just have to recover our code. So we're gonna just type password list. Or I have a better idea than writing this manually. I could just ask AI to do this for me. So I'm just gonna take a screenshot and take this piece of code and copy to the clipboard and go to Google AI Studio and open a new chat and type, please rewrite this script as it is. Do not add anything or modify anything. Just copy paste. Then I'm just gonna give him the screenshot and it's gonna just analyze this code and rewrite it. Okay, that's interesting. We've got an internal error, which is weird. Okay, so I'm just gonna do this again, rerun the code. Okay, so it's working this time. I've used Gemini 3 Pro, which is a little bit overkill, but it's fine. So yeah, this is the code that I have typed in here, the same one, which is perfect, rather than copying it line by line, which is gonna be boring and not as good. So here we just have to import the random module so that our code could work. Perfect. Everything is ready, so let me just test it out. Okay, go over here. There's an error occurred in here. That's weird. See details. Interesting. Okay. So how many letters I would like? I would like 3 letters, 3 symbols, and 3 numbers. Okay, so we need to shuffle the code. So I have to take this list, which is password list, and shuffle it first. So I'm just gonna go and choose the shuffle module in random. So I'm gonna go and see shuffle, yes. Dot how is that syntax written actually? Because I'm not actually good at remembering syntax. Okay, so we're gonna import the random, then the shuffle module. Then we're gonna call this functional and enter the list as parameter. Okay, so this is the purpose of my live streams, that if something happens and I want to revise my work, I could do that very easily, which is a very huge privilege. So we're just gonna go and grab the random module and specify the function, which is shuffle function. And hold on a second. Oh my god, this there is an AI in here as well, which is crazy. Okay, hold on a second. Okay, beautiful. There is an AI in here that analyzes the code straightforward, which is interesting. Here we have some kind of an error. Okay, we don't need to use this. What is in here? Duplicate code fragments, 10 line long. Okay, I don't care. So after we have shuffled the list, we're just gonna need to add it to a password variable. So password, yes, so we're gonna use this exactly, equals that and that. That's exactly what I'm going to do. So interesting. We're just gonna print this password. So we're using this syntax. Okay, interesting. There is some kind of AI that helps you in here, which is crazy. Okay, so this syntax, it's just taking the password list, each what do you call this? Fragment. Let's just call it a fragment. So it takes each fragment and it adds it up to the password. So it iterates through this, like it takes Y, then adds it to password F as well, until it becomes one word. Okay, so that's pretty interesting. I'm just gonna go and print this. Choose the same number, symbols, numbers, and letters. Okay, that's beautiful. It's randomized and very stylish in this. Okay, so I guess here I have stopped after I did this script. That's beautiful. So let's go over here. Compare the codes. So here she chosen a empty variable and added up with using the for loop, which is a very similar approach in here. Okay, which we have used an empty list rather than a empty string. Okay, so I guess that's way better to use a list, then shuffle it. That will do a lot of work. So there is a hard version of this script. Just see it. So the easy version. Okay, so we have here letters, symbols, and numbers. In the hard version, we have this shuffled. Okay. And we have just did the hard version with one line of code, which is crazy good. Because if you had only one variable that is already assigned to this for loop, then you have to use to transform that variable to a list, and then you have to do the same. So this is very lightweight code and practical. Okay, way better than this approach. So we're just gonna go and skip this whole project because we have made it. And then we're gonna go here and we're gonna learn about functions and Carol. Okay, so let's see the first.
Hey guys, welcome.
I'm just gonna go decrease a little bit of the sounds.
To day 6 of 100 Days of Code. And well done for making it this far. So today we're going to talk about code blocks and indentation, as well as functions, and also a different flavor from the for loops that we saw yesterday. Today we're going to talk about while loops as well. And to learn all of these things, we're going to use the help of something that's very similar to Carol the robot. And this is something I used when I first learned how to code. And it's one of my favorite tools for learning programming.
Okay, that's interesting. This seems like a squared page, and you're gonna have 3 types or 4 types of commands, which for this character in this position, if it's to go up or to go left or right or down. So we have 4 commands, which is pretty interesting. Okay.
Especially as we get into more difficult concepts like functions and while loops, etc. And by the end of the day, we're going to be writing the code that's required to instruct our little robot to be able to complete any randomly generated maze.
Okay, that's interesting. So let's get through it. So we are here in day 6. So we're gonna learn about defining functions, which is very easy. Like, let me grab a new page. It's over here, for example. And then we just say define my function, for example. A function. And then this function actually prints to me hello world. Okay. And this AI that's in here, like, it's integrated in PyCharm, which is crazy good. Okay, we're gonna just call this function, and then when we call this function, Python is gonna just interpret its definition, which is this intended line of code, and it's gonna go and execute it for us. So let's just go install this code, and it is true. Okay, beautiful. So here we have defined Python functions, which is very basic. Let's just take a quick look at it. Okay, as we have said, here we have def. We use the syntax to define. Then we have here the name of the function. And here we have these parentheses as syntax, as well as this column, just for Python to know, hey, we have named the function, and after this column, you're gonna execute what is intended in this line of code in here. Okay, beautiful. So here we're gonna go and practice in this place, which is Reeboks world. So let's do that real quick. So we're gonna go here, click on resources, and then click on here. And here we're gonna go to the Reebok website. See, we are blocking just trackers, which means that this should work just fine, right? Okay, click on the word to get some additional information. A simple empty word ready for Reeboks to explore. So the robot is located at 1-1 in this repère, like in French. I don't know how you call that in English. So let me just check that real quick. Change here the module to the Flash module. Say how to say the there in English to represent a mathematical thing. I don't know how to call that in English at all, so let's check that out together. Reference points. Okay, benchmark. Okay, interesting. So the reference point of this robot is 1-1 in this benchmark. Interesting. So let's check the course. So we have here a very very basic. So here there is nothing actually. So if you execute this function, it moves from this point to this point, etc. Very simple. And here we have turn left, which turns left, which is upwards, something like that. Yes, true. Okay. I'm just gonna go and skip all of this. So we could define our own functions using these small other functions. Okay, we could make a turn around function, which is turn left and turn left, which makes sense to turn around. Interesting. Just like that, we're gonna have a few lines of code. Okay. So as we have remarked in here, that every function is responsible for a functionality. Okay. So we have turn right, which is 3 times turn left. Okay. Interesting. Okay, so we have to draw a square, etc. Okay, so we're gonna move to the next video because this one is pretty basic.
All right,
So here we have the first maze, and we have to reach this flag. So just check that real quick. Gonna allow this pop up, and then we're gonna have our maze loaded. Okay, so we have move and turn left. And for more advanced, you may have noticed that your solution has some repeated pattern. If you know how to define functions, define a function named jump and use it to simplify your program. Okay, interesting. So we have move, and if we executed this function, it's gonna be an 2 1. Okay, so at this square, then he's gonna need to turn left, and it's gonna be into 2. Okay, so we're just gonna add here turn left. So after this, he needs to move. So we need to do a combination. Okay, and then we're gonna use here the move function. Okay, so we're gonna go and define a function in here. It's gonna be very useful for us. I'm gonna define turn left and move. Okay, turn left, move. I know this is a useful thing to do. So we're gonna just indent this thing as well, this function. So after we execute move and then turn left and move, which is this function, turn left and move, then we're gonna be at this point. So we're gonna need to turn left first time, second time, and third time. We're gonna need to do that 3 times. Okay, so let's do it. Turn left. Hold on a second, and then we're gonna copy this 3 times, just like this, and then we're gonna have to move. Okay. Okay, and then I guess this function is just unnecessary. Okay. Because we're gonna define a function which is to jump. Just gonna go and simplify all of this. Okay, so let's just make it happen. Turn left. Let's write this down. Turn left. It's gonna move, turn left, and move again. Then we're gonna turn left and turn left and then turn left, and then we are going to move. Then we're gonna have to turn left, and then turn left 3 times. Okay, here we're gonna now type turn left, Okay, turn left. Then we're gonna type another turn left in here. And we're gonna need to move and turn left for the last time, okay? Move, then turn left. So our jump function starts from here. So we're gonna define all of this code in the jump function. So jump, and we need a column in here. Then we're gonna intend these lines of code. If you okay, perfect. So, and then we're gonna call the jump function. Okay. Let's see if this works. If we get our first obstacle. Okay, it seems to function. Indeed. Okay, beautiful. Beautiful. So this functions. So we're gonna need to jump 1, 2, 3, 4, 5, 6 times. So which is crazy good. So we're gonna just copy this, delete it, put it at the first of the script. So always define your functions at the beginning of the script so that you could differentiate them. Okay. So we're gonna use this combination 6 times. Okay. So this is the first time, second, third, fourth, fifth, and sixth. Then we're gonna execute the code. Very easy. Okay, so it's gonna happen automatically. All of this work. Okay, it seems to work just fine. Okay, we are at the middle. Then we have just 3 left obstacles. Okay, just 2. And then just 1, and we are immediately done. Okay. Okay, perfect. So we have made this challenge with ease. Okay, let's move. So she's gonna do something similar to what I did. Okay, so she defines this as turn right, which is pretty interesting function. Might do help, but who knows? Like you could define a way better, which is with a jump function. You could actually define 2 functions, which is when we are here. So we move, we turn left, then we move. There is turn left 3 times, which is turn right. And we could see the turn right function being used here 2 times. So we could just define it as well. So let's define turn right. And then we're gonna need a column, and then we're gonna need to copy turn left 3 times real quick. Okay, so it's copied. Then we're gonna go and call this function rather than typing turn left 3 times, which is not that much of a practical usage. Okay, we're gonna delete this one as well, and then we're gonna have the same code executed. Okay, let's just check that out. Yes, that's true. So we're gonna see here that if we had called jump or turn right, then Python just executes what's defined inside of the function and execute it as a whole in the script. Okay, that's beautiful. So this manner of coding is not maintainable. Okay, I'm gonna get stuck pretty quick if you wanted to debug something. So make your functions and try to not repeat code as so. Yeah, if code was repetitive, this is gonna be problematic. Okay, so rather than calling this move jump, you could call this obstacle. So we're gonna define another function, which is our 3rd function, and we're gonna call it obstacle. Okay, so we're gonna define obstacle, obstacle or step. I don't know. step obstacle. Okay, this one's pretty good for maintenance. If you want to debug, you have to name your functions based on their functionality, so you have to think about that. Very important step while defining functions. Okay, so we're gonna need to use step obstacle 6 times. Rather than writing this repetitive in boring code, we're gonna just call step obstacle 6 times. So we're gonna just copy it and paste it 6 times. Okay, 3, 4, 5, and 6. So we're gonna have the same result as well. Okay, so yes, that's just functioning like butter. Okay. So this code is way better to do it, and we could actually use rather than repeating step obstacle 6 times, we could use a for loop that does the work for us. So for step in range 6, range of 6 times. Okay, we need a column in here. Okay, I'm gonna attend one step obstacle function. Okay, we're gonna intend that. Then we're gonna have the same result. Yes, exactly. So let's just see if we reach the end result. Okay, so we have here 5, 6, 7. Okay, beautiful. Then we have here 8, 9, because it's working just fine. So look at this code, it's pretty short and it's very less repetitive. Okay, and compare it with this code of the teacher, like you can't actually debug this thing because just all the time repeating and it's not that maintainable. So here we have divided this boring, locking, and unreadable code to 3 readable functions, which is to turn right, to jump, and to step an obstacle. And rather than calling the obstacle 6 times manually, we could just use a for loop, and we could iterate 6 times in this range. So 6 times and call the function. So yeah, so this is how you write code, and you shouldn't write it like this. So this is a very important lesson.
50.
Let's see if we have another maze that we could play with. Okay, so let's just skip this. So yeah, see, she just used the same thing, but she didn't use the third function, which is to step an obstacle. She just made all of that in one function, which is a very bad approach, because jumping, it should begin from this place, which is the robot is gonna be facing this red line, and then he's gonna need to turn left, and then he's gonna need to turn right, then to move, and then turn right, and then to move, and then to turn left. Okay, so this is a jump. So this is the functionality. So for each functionality, you should make a function for an easier debug. Okay, and this is another function, which is to go from another square to get to the jump. This is another functionality and should be named as another function. Okay, so if you could differentiate between these two functions, is the best way to get the job done. Okay, so don't do this approach as well. Here she used the same mechanism, okay, for the for loop. Okay, let's check this video and see if we could learn something. See, we could define my function, and then we're gonna print hello. This is a very basic function. Okay, still basic. Okay, if we didn't intend the code, Python is not going to make this a part of the function when you call it. So it's not going to execute this if you call the function, which is obvious. She makes an example here, and the folder manager, which is a very silly way to make an example of. Okay, interesting. Let's just skip this. So here we see the importance of indentation in Python. So same concept goes for the f, elif statements, etc. Okay. So we skip all of this because it's very basic. Okay. So here we have spaces versus tabs. Okay, this is a very important section, and it is funny as well. If you have watched this TV show, which is Silk Road, I don't remember that. Silk Road's TV show, I guess. I don't know. I don't really remember it. The name of it. No. It was very similar names. Just ask AI. What is the name of the comedy Nerds Tech TV show? Okay, let's see. I'm gonna take some time. Yes, Silicon Valley. Okay. So if you have watched this show, Silicon Valley, you're gonna know the difference between tabs and spaces. So it's very silly. Okay. Let's just watch that on YouTube real quick. So we're gonna go to YouTube, Silicon Valley, tabs versus spaces, and then we have a 2-minute short clip. Okay, check it out. So here we have the main character, and here is his girlfriend. Okay, and he's kind of annoyed to see somebody use tabs, which is in code. Tabs do not get interpreted in the machine code. It doesn't get interpreted as spaces, and that creates problems in the long term. So, and he's pretty annoyed because of that.
Yeah, all good, great.
So he just, doesn't express that, but he's gonna do it anyways.
What?
My roommate's going out of town tomorrow, so if we want
So he's still pretty annoyed after all of that.
to come back here after Erlic's party.
Oh, okay, yeah, sure, that sounds good to me.
All right, it's a date.
See you then.
Okay. So he still hears those spaces. Look at that. So he hears 4 spaces, which is pretty annoying. And he hears it again. Oh my god, this is so much annoying. He can't do it. Oh, help.
Richard, what's wrong?
Nothing, literally, it's all good.
So he just can't hear those 4 spaces. Oh my god.
Come on.
Oh my god.
I'm sorry.
Your
So he reacts to it.
roommates are right. You really hate spaces.
No, I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's
Okay. So here he's gonna explain his trauma.
only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces?
Yes, so she has a point. If you really want to be specific, you just type 4 spaces. which is way better than using a tab. But in the note code that we used, this problem has been fixed, I guess, of precision. So
But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah.
look at
Yeah,
this.
technically,
So if the code has been compiled, then there is no difference. Okay,
yes.
technically, yeah.
I guess I just don't understand why anyone would use spaces over tabs. Like if it's all the same, well,
So he's gonna here explain.
why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes.
So this Silicon Valley is because of it's based on a company that targets compression of files. So this why so for this reason he hates spaces, because they are not as easily compressed as tabs.
All right, I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean,
Which is this is very stupid. Like, who cares about that compression?
why not just use Vim over Emacs?
Oh my god, Vim. I just don't use Vim because maybe later in my life, if I had to. Because people use it because it is very tailoring. You could tailor that, it customize that in a very specific matter. So that's why people prefer Vim.
I do use Vim.
Oh, God help us. Okay, you know what? I just...
So after this, he just decided to break. Okay, to break, whatever. So let's continue.
2 ways of
So she explains the same thing and brings us the same TV show. Let's look at that real quick. Okay,
Your roommates are right. You really hate space.
so he really hates spaces, etc. So it's pretty neat. Let's continue. Okay, here she explains about the developers who uses spaces and tabs and the difference between salary. So he uses spaces are more precise, which means they earn more. So pretty interesting. Okay, I had a spam call. Like, it's lately a lot of spams calling me. It's pretty annoying. But who cares about that? So just continue. So she explains that, and this is pretty nerd information, unnecessary. Okay, so we're gonna go to the while loops. So the while loop is
Very good.
different than the for loop. Okay. So it depends on a condition, like, so while this condition is true, execute this amount of codes. If this condition is not true anymore, then break the while loop. So it is as simple as that. Okay. So here we have the difference between them. So while something is true, do it. And for this item in this list, so for loop is way better for iteration purposes, and while loop is way better for cases, for catching a case. Okay. So a case could be true, could be false, but for loops are way better if you had to count something that's in a dictionary or in a list. And yes, way better for iteration, way better for cases. So this is the difference between these two loops. Okay. The try-to loop. So that's the concept. Okay. So perfect. Here we have another challenge. Okay. Okay, interesting. Here we have number of hurdles. So while number of hurdles is bigger than 0, jump. Okay, interesting. So while number of hurdles, okay, so so this is gonna be infinite. Okay. So if we just used Python our terminal, and we have typed this condition, which is number equals 6. So while number is bigger than 0, then I'm gonna here make a column, then print. Okay, then I'm gonna use two strings, sorry. Then I'm gonna print true, for example. So yes. So I don't know how to use the terminal with this. It's a little bit difficult to do. Okay, interesting. Interesting. So here we have an indentation error. So 1, 2, 3, 4. Okay. So we have here true, 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 true. It is infinite. Okay. We just, interprets with the keyboard this execution. Like, look at the amount. It's just crazy. Like here we have a crazy amount of true. So just create this, exit. So just to know, this is an infinite while loop. So because this condition is gonna stay true forever, for eternity. So to actually make this better, we could use I guess for loop is better, but we could use something different. So we could just comment out this. Oh my god, this is a very bad code editor, because you want to comment out this stuff. Okay, so we're gonna use number of hurdles is going to be equivalent to 6 hurdles. Then I'm going to make a while loop, while number of hurdles. Let me just copy that rather than retype it. Paste it. While number of hurdles is bigger than 0, then I'm going to step an obstacle. Beautiful. Okay, and we need to make some new lines. Okay, so before this happens, we need to, for each loop, we need to make this number come to 0. Okay, so we're gonna need to minus this number. So we're gonna take the same thing, and then we're gonna use this syntax. and then we're gonna hit type 1, so it just takes this variable and then it makes it less and less with time. So we're just gonna test that on our terminal. Okay, so we're gonna type here Python 3, and we're going to define number is going to be equivalent to 6. I'm going to type here a while loop of if number was bigger than 0. I'm going to need a column, then print true. Okay. Oh no, ugh, I need to define this even better, sorry. Okay, so we're just gonna go and minus this number with a 1. Okay, beautiful. So we have here 6 truths, 1 2 3 1 2 3, and after number becomes equivalent to 0, this while loop is gonna break. Okay, so beautiful. It's just clear. Okay, that's neat. So we're gonna go and execute this, and we're gonna have the same result. Okay, let's just execute it, and we're gonna have the same results as with the for loop. So indeed, for and while loop could be similar in a specific manner, but a for loop is way better than using a while loop, because for loop uses just 2 lines of codes rather than a while loop using 1 2 3 4 lines of code, which is not as practical as a for loop. Okay, so iteration use for loop, for case handling use while loop. Okay, because for loop can't just catch a case, because you know that's its nature. Interesting. So let's continue. Okay, so she just explains the same thing. So she uses the same kind of mechanism, which is interesting. Okay, she explains the same thing. Okay, here we have another challenge, which is hold race. So Reebok has entered a hold race, but he doesn't know in advance how long the race is. Make him run the course following a path similar to the one shown, but stopping at the only flag that will be shown after the race has started. So what you need to know, the functions move, and okay, so we're gonna use a while loop because to test if we are reach the goal. If not, then we are going to step an obstacle. Okay, yes indeed. Okay, so this is gonna be very easy challenge. Just look at me do it. Oh man, this is gonna be very easy after we know how to do it. So we're gonna go and import this code. We are just gonna go and use this function as our condition. Okay, so the condition at goal and its negation. Interesting. We're gonna have move, turn left, and while loop. Interesting. Okay, so we have this code imported. So we're not gonna use a for loop in this manner. Well, I'm not gonna use this condition anymore. We're gonna use at goal goal, and then we're gonna use while at goal is true, is false actually, is false. Oh my god, what did I do? So if this was false, then step. Okay, I'm not gonna need this line of code because right now we are catching a case. Okay, if we have reached the goal, then we are going to stop. If we didn't, then we are going to step an obstacle. Okay, so let's just launch this. Okay, that's interesting. Okay. Okay, so we have to make this as a function, which is a typo, but this should work. Okay, so it's working right now. Because the function is already defined in the database and this is imported. So this should work because we have called this function to have the boolean, okay? So let me just explain what happened. So this function all the way through, she was false, okay? So at this square false, this square false, this square false, and this square has a set of coordinations. So 1 1 false, 2 2 false, 3 1 false, etc until 7 1. 7 1 is the only square that has the value true, and because the value is true, this while loop is gonna break, okay? And we could do this all the time and we're gonna have the same result, okay? So just repeat this. Maybe the true value is gonna be at this place or this place. It's gonna be randomized. Okay, I just want a far place rather than the middle. Okay, let's see. Okay, so we're gonna move and move and move until we have that condition true. Okay, so let's see. Okay, so it's going and going. Oh, that is good. Okay, by the way, I forgot to use something very important, which is to change the title of this live stream. So I had to change it. Learning how to code with Python. Okay, 100 days challenge. Okay, beautiful. I'm gonna save it. Okay, beautiful. So we have changed the title of the live stream. Okay, interesting. So we could just exit this and focus. Okay, beautiful. So this challenge is done and we have made it with a very few lines of code. In total we have 19 more. So if we deleted these 2 lines, then we're gonna have 17 lines of code, okay? Which is very minimal, lightweight code and minimalistic, okay? So just move on to this and check this.
Alright guys, it's time for yet another coding challenge, and this coding challenge is gonna put into use what you've learned about...
Okay, thank you. I'm just gonna check these as if they were made, because they are very basic and stupid at the same time. So we have made while loops, now we have hurdles, challenge using while loops. Okay, so we might have another challenge. Interesting, let's just go to the resource and get that challenge uploaded to us. So we are speedrunning these challenges because they are very easy if you know how to play with the logic of code. So the function is move and turn left. The condition is front is clear, or wall in front at goal and their negation. How to use a while loop and an if statement. So okay, and then we have front is clear, or wall in front, or at goal. So we're gonna have 3 conditions that have a boolean value, which is true or false, and we're gonna need a lot of thinking. And then we're gonna have how to use a while loop and an if statement. Okay, interesting. So we're gonna use an if statement inside of a while loop, and we're gonna have these 3 functions. Okay, so we're gonna need to make a comment to just save these functions and have them in our head before doing this. So we're gonna have a little bit of flexibility in this case. Okay, so this is a little bit more difficult. Okay, so so we're gonna have wall in front, then we're gonna jump. Interesting. And if okay, interesting. So we're gonna use this while loop to reach the goal. So we're not gonna change it, but we're not gonna have a simple step obstacle. It's gonna be a little bit more sophisticated. So we're gonna have this boolean added, which is if wall in front, then we're gonna jump. Okay, there we are going to jump. Interesting. And if front is clear, so we're gonna use an elif statement, elif, and then we're gonna have if front is clear, then we're gonna move elif, front is clear. So here we're gonna type is true. We're gonna jump is true. Then we are going to move, and so we're gonna do jump, move. If front wasn't clear, if there is a wall, we're gonna jump, etc. And if this was false, then we're gonna, so this is gonna be very enough. So this function we are not gonna use, so we're just gonna comment it out. Okay, because we're gonna need to use if and elif statements in this case. And I guess this is very enough to reach the goal. So let's hope this works. Please work. Please work. Okay, so it's working. Okay, interesting. And then we are jumping because there is a wall in front. Okay, there is no wall in front, so we're gonna just move. Okay, that's very interesting. Okay, fine. Okay, so it's working like butter actually. Oh my god, this is so much good. There is no wall, we're just gonna move normally like a human being. Then we're gonna jump if we find a hurdle. Then we're gonna jump and then we have reached the goal. Oh my god, this is just beautiful code. So if you had deleted these 3 lines of code, I'm just gonna copy them and delete them real quick. Copy and delete. So we're gonna have 17 lines of code that does all of this, which is crazy good. Okay, just gonna go and recover our lines of code that were commented out. Okay, let's add the commentary in here. Beautiful. So this script actually defeats this challenge pretty perfectly, which is interesting. Okay, so we're gonna skip this. She's gonna use the same okay, yes. Oh, she used only else. Oh my god. If you use else, it's like not initialize the functions as they should be. And you are not catching all cases actually, so which is enough actually. So yeah, so this is gonna go and do the work. Yes, because we are having just 2 cases in this challenge, but in the next challenge we're gonna have more than 1 case actually.
All right, guys.
Oh my goodness. So the hurdle or the jump is gonna be variable. Holy moly, this is gonna be way harder. Okay, let's get the challenge. It's gonna allow this link. Okay, we don't have any new functions, so let's just read this. Holders race. Racebook has entered a holder race Make a home around the course following the path shown. The position, the height, and the number of holders changes each time the sword is reloaded. What you need to know, you should be able to write programs that are valid for worlds around 4 and holders 3 and combine them for this last holders race. Okay, so you should be able to write programs that are valid for worlds 4. Okay, so we should combine what we have learned. Your program should be valid for worlds 1, 2, and 3. Okay, interesting. Okay, so these are the functions that we have to utilize. So this function is gonna be utilized. So this function, this if statement, we have to modify 100%. Okay, there is no problem with it actually. If front is clear, we're gonna move. So let's just imagine here we have a wall. So we are going to turn left and then we're going to move. And if the front is clear, then we're going to need to turn right. And so we're going to need to modify this jump function. Okay. And we're going to add if statements in here. Okay. So let's just see how we could reprogram the function for it to be a variable more adaptive to more cases. Okay, so we're gonna use if wall in front, so we're not gonna use this. Okay, interesting. We are going to turn left, left. Okay, and then we are going to move and move. Okay, front is clear, wall in front. Okay, so if okay, interesting. There is no other functions that we could utilize because that's kind of I guess we need another function. I don't know how to check that. 3-box keyboard. Yes. So we have here move, turn left, take, put, toss, build wall, pause, don't think, sound, world, use robot, no highlight, conditions. At goal, front is clear, right is clear, so we're gonna need to utilize this function. Wall in front, wall on right. Okay, so we're gonna use this wall on right if we have a wall on right. So okay, interesting. If we have so we're gonna use a while wall on the right. Okay, so we need more functions. That's pretty obvious, isn't it? So while wall on the right, then we could just move straight forward, and if this falls, then in here we are going to break the while loop, and then we're gonna need to turn right. So turn right, exactly. And if we turned right, then we're gonna need to move. Yes, exactly. Okay, and we're gonna need to turn again. Turn right. Exactly, turn right. And then we're gonna go and we're gonna need another function. So wall on the right, we're not gonna use that. Wall in front. So if there was a wall in front, in this case in here, so we're gonna reach in here. So we're just go and say if wall in front, then we're gonna call this function. If this function is true, to just make it more readable, then we're gonna need to turn left. We're gonna need to turn left. Interesting. And we're gonna need to turn left again. But we need to check on something. So we turn left, and then we're gonna have this one. If front is clear, then move. If it was false, then we're gonna jump. And then if we're gonna jump, then we're gonna turn left one time. And then we're gonna see if okay. So this is perfect. This should work. Okay. Because if we added here turn left, then this is gonna go and make this elif statement useless. Okay. And we're gonna make everything just not function as it's supposed to be. So let's see how this is gonna function. I think we're gonna have a bug because this is a little bit complicated. Well, let's see. Okay, so we are moving and moving and moving. And do we have a bug? Yes. And we have the bug in here. Oh, so this is considered a wall actually. Oh, problematic. That is problematic. I'm not kidding. Okay. Okay, interesting. So after we've done this, we have turned right. If wall in front, we have turned left. And then this has been interpreted as front is not clear. Then we're gonna need to move, right? That's weird. Yes, so we have turned left in here. And then this has been interpreted as wall on right. Okay. Front is clear, right is clear. Wall in front, so we're gonna need to use this wall in front as well. Okay. So wall on right, and we're gonna need to add another statement. Wall on right, and front is clear. Okay. In this case, we could move. So front is clear. So this should fix the bug. Okay, let's see. Okay, so we're gonna run this step by step. Let me just get back. Okay, so get back even more. Okay, so this is the beginning. So the front is clear as our while loop, so we're gonna move. Interesting. That is done. Then we're gonna go. We are not at goal. Wall is in front, which is the case, and then we're gonna jump actually, and then we're gonna go and execute the jump function. We're gonna turn left, and then we're gonna go and check the statements. If there is a wall on the right in front is clear, we should move, and that's what we do in here. So we move. So this is wall on the right is false, and this one is true. So this while break is gonna break. This while loop is gonna break, and then we are not gonna execute move, right? What happens? Okay, wall on the right. There is no wall on the right. In front is clear. What? Okay, this is not being interpreted from the first place. Okay. Okay, that's interesting. We didn't call a function. That's stupid. So let's just repeat this, okay? Stop it, and then we're gonna go. So front is clear, we could move. That's true. We have while. We're gonna go and execute the while loop again. And then we have front is not clear, so we're gonna jump. Yeah, wall if is in front, so we're gonna jump. And then we're gonna turn left. And then we're gonna check on a while loop. And the jump function. Is it actually good to use that? I don't know. I guess you shouldn't use a while loop in a function, but let's see if that functions. If not, we're gonna go and delete the while loop and use only if statements, which is maybe more reliable. I don't know. So we're gonna move, but actually it is way better because we are jumping a hurdle and we're gonna need to use a while loop, because one if statement is not gonna be enough and it's gonna make more problems. So using a while loop in this function, which is jump, is pretty useful in our case. So we're gonna check wall on the right, which is true, and front is clear, which is true, and we are going to move. Okay, so here wall on the right is false, which will break this while loop, and then we are going to turn right like a civilized robot, and then we are going to move, and then we are going to turn right, just get that hurdle done. Okay, so if wall in front is true, then turn left, but there is no wall in front, so we're gonna go and apply this while loop, the original while loop. So we are not at goal, and if wall in front, then we're gonna jump. There is no wall in front, so we're gonna move, and we're gonna move again. So there is a wall in front. Oh my god, here we're gonna have a bug. Okay, so here we have a wall in front, right? But our left, our right actually is clear. So we're gonna need to add this. So we're gonna add it in here. We're gonna make this an elif statement, and we're gonna make here an if wall in front, which is our case. If wall in front, and actually we could delete this because it is just to make it more readable at the beginning, but it is not that necessary. Okay, beautiful. Okay, so we're gonna make this if statements, if wall in front and right is clear, and right is clear, which is this case. Then we are going to turn left like this, and we are going to move. Okay, and move. Yes, that's correct. So this is the function that we needed to add, and then we have an elif in here. If wall in front and right is not clear. Okay. Interesting. Is and right is not clear. Okay. And right is not clear, and not right is clear. We're just gonna copy this right over here, and just like that we have catched more cases, which would make our script more adaptive. So here we're gonna have a bug. Okay, oh my god, it takes the if statement that I have just made, or what? No way. What happened in here? So, oh my god, can't I repeat this? No, I can't. Okay, here we have an error. Cannot assign to function call. Could not analyze the error. You might want to contact my program with a description of this problem. Something's wrong. Syntax is wrong. Okay, what happened? So here we have wall in front. Okay, and right is not clear. So we're gonna skip this. Oh, so this is the syntax problem that we have. Okay, interesting. If wall in front, which is true, and right is not clear, which is true, then we are going to jump. Okay, so this should function. Let's see. Okay, this is false, so we're gonna skip it. This is true, so we're gonna use it. And then we're gonna start our jump sequence. We are going to jump as first, and then we are going to check this while loop. If wall on right, which is true, in front is clear, so it is true, so we're gonna just move. All of this is true. So this has just braked because there is no wall on right, so this has been braked. So for that reason, we are going to turn right, and then we are going to move and again turn right. Okay, and then we are going to use our while loop, and we're gonna check our front is clear and our right is clear, so we are going to jump. Okay, wall in front, right is clear. This one is false. Okay, how to right is clear. Okay, front is clear. Okay, wall on right, wall in front. Okay, interesting. Interesting. Here we are going to jump again, which is, oh, hold on a second, what happened? Okay, wall in front. There is no wall in front in here. Wall in front, there is no wall in front in here. Right is clear, that's all true. Okay, so all of this is gonna be skipped. Interesting. And then here we have front is clear. Okay, interesting. So we have checked these two cases, and then we are just going to move again, so the same is gonna happen. Then here we have while at goal is false, which we haven't reached the goal. We are going to check again. If wall in front and right is clear, wall is front and right is clear, then we are going to turn left and move, which is correct. Okay. Oh, why do we jump? What the hell? What happens in here? So here, wall in front, true. And right is clear, true. Why did we skip this? Why did we skip this? I don't get it. Explain this to me. Why did we skip this? This shouldn't be skipped. Because we have here wall in our front, which is true. And then our right is clear, which is true. Why did we skip this? I don't get it. Why did we choose this? Wall in front. Interesting. I don't get it because I don't get this. Why did we skip this? So this one is this case. For real. Yeah, this is false. I know. So for some reason, we choose this elif and we don't choose this F statement. That's weird. That's weird. So our front is clear. No, there is a wall in front. True. As if this statement. Okay. Interesting. That's pretty interesting. So we mean right this direction. Uh-huh. Uh-huh, uh-huh. Okay. Okay, so we're just gonna go and replace this. I don't know. Okay, we're just gonna copy all of this and paste it in here. Okay, so this is our same codes, and then we're gonna go and replace this. So okay, just gonna go and replace these two and see if that would work. Okay, start this, stop it. Okay, let's troubleshoot this step by step. So we are going to start our while loop. Then we're gonna check if wall in front and right is not clear. Then we are going to turn left. No. Oh my god, I don't know what's this syntax because this is weird. Our right is not clear. We mean right this square. Okay. Okay, so these functions are a little bit weird because this is not right, this is left for me, and this is right where there is a wall. Weird. Okay, let's continue. Wall in front and right is clear. There is no wall in front, so we're just gonna skip this. Why did we skip this and this as well? Because there is no wall in front, so we're gonna go and move. Okay, let's move. Okay, here we have a wall in front and our right is not clear. So if this has been executed, yes. Okay, and then we're gonna move. True. So this one is false. We have no wall in our front. Oh my god. Oh my god. So this is gonna make this issue. My head. So here we have made our first mistake. Okay. So F wall in front. Okay, interesting. So this happens after we execute this weird function in here. So we're gonna need to make it more sophisticated. So we are going to execute front is clear. Okay. Okay, interesting. So we have to modify this function. Okay, this one. So our front is clear right over here. Our right is clear. So yeah, front is clear and our right is clear. Is clear. Front is clear, right is clear. Then we're gonna do okay. That is clear. Then we are going to turn left. Okay, so we turn left. Okay, interesting. So here we turn left and we move. And then here we turn left. Okay, here we turn left and then we move. And then we turn right. So we are making a jump in here, which is a little bit not as optimal. This is not how this code should work actually. But it's okay. So we're gonna turn right and then we are going to move. Okay, let's just troubleshoot this. Okay, this is a little bit sophisticated. Okay, interesting. So we're gonna go and make another case, which is another elif, and it's gonna be if front is clear and right is not clear, and right is not clear. Okay, I'm gonna make a column. We are going to just move. Okay. Interesting. So let's execute this. Okay, so let's analyze this code. So while if there is no wall, so we're gonna skip this and skip this, and we're gonna skip this as well, and we're gonna use only this, and we're gonna move. Okay, so here while in front and our right is not clear, so we are going to turn left and move, and there is no wall, so we're gonna skip. Here there is an elif, which is front is clear and right is clear, which is gonna be skipped, and then we're gonna see this. If front is clear and right is not clear, then we're gonna just move. And it's the same thing that we do in here, same thing we do in here. And then here, wall in front. Okay, there is no wall in front. Okay, in here we are going to jump. Hold on a second. There is a wall in front and our right is clear. Then we are going to jump. We are going to turn left. Oh my god, this whole code is kidding me. Okay, interesting. I would have to repeat all of this actually. Yeah, I'm gonna take a break. I'm gonna delete all of this. This is a failure. This is just overcomplicated, and we're gonna just start anew with this. Okay, so we're gonna start anew, and yeah, I'm gonna make this work 100%. I'm gonna take a break, refresh my mind, and we're gonna get back to this. Okay, so we're back. So I have to make this work. Just repeat this guy. Okay. So we're gonna focus it here. We're not gonna go and step an obstacle. This function is a little bit unnecessary, but we're gonna need to define some functions. Okay. So before defining anything, I'm just gonna go and try to troubleshoot this. Here we have our front clear and right is not clear. Okay. There is a wall on the right. Okay, let's just use wall on the right and front is clear. So yeah, so if front is clear, front is clear, and our right is, there's a wall and the right, the wall on right, then we are going to move. Okay, see this? Okay, we move, and okay, interesting. So I'm gonna call this a function. I'm going to define it. I'm gonna call it ground walking, like this. Ground walking, beautiful column. I'm gonna paste this. I'm gonna make some indentation over here. Beautiful. Okay, nice. So the first thing we are going to do, okay, interesting. Okay, so each time we are okay. So actually defining functions in here is gonna be very variable. So we're gonna actually repeat this if statement, which would make these functions unnecessary, because this is variable. Okay, the ground walking, and to actually spot this ground walking behavior, we are going to use an if statement in here. So it's gonna be repetitive codes, and this is not what we want. Okay, so we're not gonna define functions. Okay, interesting. Okay, so here I'm just gonna go and make an indentation, correct. Okay, beautiful. So let me just run this code, execute this step, and we are not at goal, and this condition we have. So I make another LF. So here we have our front, there is a wall in front, so wall and front, and we have on our right, there is a wall on the right, wall on right. Okay, then we are going to jump. Okay, fine. So in this case we should jump, so we are going to turn left, then we are going to move. So first thing, we are going to turn left. True. We're going to just delete this. And then if there is front is clear, if front is clear, okay, and there is a wall on the right, wall on right, then we are going to move. And because this is a variable, so we're not gonna use an if statement but a while loop. Okay, a while loop. And if we have reached this spot in here and this has been broken, then they see. So here we have our front clear, our right clear. So we're not gonna go and execute this. So we're gonna go and jump and work on our jump function even more. So here we're gonna have an if statement if front is clear. Okay. And if if right is clear as well, so and right is clear, then we are going to turn left. Okay, after we turn left, then we are going to move, and then we are going to turn left again. Not left, but actually right. Okay, that's a mistake. Turn right and turn right. Okay, so we're going to do this sequence, and if that happens, then we are going to move as well. Okay, so we are in this point, then we have to check if this wall over here, so I'm gonna have another if statement. It's gonna be an elif. It's gonna be an if statement, another if statement, and this while loop. And when this is done, then we're gonna move to this. So that's why we're not gonna use an elif. So this is done. We are in here, and we have to make sure that our front is clear and our right is clear. Then if our front, okay, front is clear and our right is, so I'm just repeating this same thing. Okay, interesting. So we're gonna have this okay, interesting. Okay. So because we're gonna just do another loop in here, so we're gonna use a while loop. Okay, another while loop. No. If we is here, and while loop is not gonna be as good, because we're gonna repeat this whole sequence. Okay, I'm just gonna use an if statement. So let's see where this actually goes. We're gonna repeat this whole thing. So here our front is clear and there is a wall on the right. We're gonna skip this. We have our wall in front and wall on the right. Then we are going to jump. I'm going to turn left. Then our front is clear and there is a wall on the right. Then we're gonna just do this while loop. And then here we have our front is clear and the right is clear, so we are going to turn right and move, and then turn right, then move. Okay, interesting. Okay. Okay, so here we're gonna add if we're gonna just add here a while loop, actually, while, and if there is no wall in here, like here there is no wall, there is no wall, if front is clear, you see if front is clear, then we're gonna do we're gonna just move in this case. Okay, and if there is a wall, then we have to complete our jump. Okay, we're gonna need to make a successful jump. So that if this has been broken, then we have to turn left. Okay, we have to turn left and then we are going to reset. Okay, so this is a successful jump function, so it jumps no matter how the hurdle long. Okay, so we're gonna repeat right now. We are going to launch our code. So we're gonna jump on this thing. So if front is clear and there is so we're gonna just skip this one. Okay, so we're gonna move, we turn left and then we do one move, then this is broken. Okay, then here we have our sequence, front is clear and right is clear, then we are going to turn right and move. Okay, okay, beautiful. So we're gonna skip this while loop and we are going to just turn left and we are going to get back and reset from the beginning, and this should be successful. Okay, so let's just try it. Please be successful. Please pray with me, pray with me, pray with me. Please be successful. Okay, it seems to be functioning. As I said, if you want to code and you had a problem or place that you are stuck at, just take it. Oh my god, no freaking way, what happened? No, what happened in here? There is a problem in here. Okay, I thought this was perfect. Come on. Okay, let's see. So we have just finished from this. Front is clear and there is a wall on the right, which is correct, so we move. Okay, just get back. Okay, front is not clear. Okay, interesting. Okay, here it's a little bit interesting. Okay, let's get back a little bit. Front is clear and right is clear. We should do this. But our front in here is not as clear. Okay, that's why it doesn't work. That's why we have skipped it. Okay, it's just we get back in here. That's why we have skipped it, because the front here is not clear. Now how to overcome this? Interesting. We're gonna add something in here. Front is clear, right is clear. Maybe we need to delete this thing, which is front is clear. If our right is clear, then we're gonna do this. So this condition may be the problem. So let's troubleshoot this. Repeat again. So this one, let's see if it is successful. Okay, interesting. So yes, this one is successful. So this is the bug that was in there. Okay, so this one's gonna be successful in everything. Beautiful. Okay, you have to think of logic, otherwise you're never gonna make this. If you have a good logic, you could actually make any challenge. Then we are going to break this when we reach the goal, this while loop. Beautiful. So just try when a hurdle touches the roof, like this one and this one and this one, and see if it is successful. Because I guess it's going to be successful because we are not checking if the front is clear. We are just checking if the right is clear. Okay. So this should be successful. Yes, exactly. So we have fixed the bug. And right now it functions like butter. Okay. Yeah, taking a break, and actually yeah, that's the solution. For me to take a break, think less, and then restart from scratch. This was the solution for this challenge. It seems to function so much good. So this is an algorithm to skip all of these hurdles. Okay. Beautiful. That's beautiful. Then we have only one hurdle, and then we have reached our goal. Like, no matter the variables of these hurdles, we make them just right. That's beautiful. Then it's done. So this script is looking like this. Interesting. Right is clear. Okay. We could make some functions, but it's not that necessary. So yeah, that's my script. So let's compare this to the script of the teacher. Okay, so she makes a while loop in here, while on right, then we are going to move, etc. Okay, while front is clear, we are going to move and then turn left at the end. That's interesting. Yeah, so she uses a very similar algorithm.
Generate our map.
So yeah, pretty interesting. So it's complete.
All right,
So here we have another maze. It's going to be a little bit complicated, I guess.
guys, it's time for the final project of today. And the goal is to be able to write some code here in Reborg's world to be able to get our little robot to be able to navigate to the goal and go through a maze no matter what the maze looks like. So if you go back to Reborg's world, if you already got a link open, if you don't, then simply click on the direct.
Okay, so she just talks. Okay, so it's here.
And it should take you here. And we've got the maze selected in the drop down, which is right here. Here we have a maze. And even though the maze doesn't change, the robot does. The direction that the robot is going to face is completely random. The position of the robot is also random. So you can see every time I restart the game, it will face a different direction. So in this case, it's facing up, but the next time it might be facing down in this case. And it's also always going to start at a random location in the maze.
Okay, that's interesting. So let's get this challenge done. Does seem to be a lot random. You have to catch a lot of cases. So it's gonna be a lot of work. Let's get it done, okay? Okay, so we just need to go and select this maze. Okay, beautiful. So we have these functions. Front is clear, wall in front, right is clear, or wall on right, and that's goal. How to use while loop, if, elif, and else statements. It might be useful to know how to use the negation of a test, not in Python. Okay, interesting. See here we could see the keyboard. See the functions that we have. Take, put, toss, build wall, pause, no highlights, eavesdrop, words, sound, conditions. It's goal, front is clear, right is clear, all in front, wall on right. Object here carries is facing north. That's pretty interesting. I have Python. Okay. These are the conditions that we have to work with. And we could actually remove all of this because this is not a hurdle anymore, it's a maze. So let's see how we could do this. Interesting. Okay. So we're gonna see if there is maybe a wall, if front is clear, so we're gonna use this. If front is clear, then we are going to move, right? Because our front is clear, so it is very normal for us to move as a robot in the maze, right? So I'm gonna make a while loop with this and see where this goes. Okay, interesting. So our front is clear. Okay. Let's repeat this. Oh my god, this fails so much fast. Okay, let's see. So our front is clear. We move. And then our front is clear, we move. Our front is not clear. Interesting. So if this while loop just breaks. Okay, so the first while loop we are going to use is at goal. This is the most important one, the main while loop. Then we're gonna see if front is clear, we are going to move. If the front wasn't clear, we are going to check if right is clear. Here's another elif statement. If right is clear, then we are going to turn right. Right. And if our right wasn't clear, then we are going to check if okay, interesting. That's very interesting. Let's see here. When do we turn left? This is so much random actually. So when do we turn left? If our front is not clear, something like that. I don't know actually. So let's just test this out. Okay, it doesn't function. Not at all. Okay, this is problematic. because it fails directly. Okay, while at goal, while not at goal. This is the problem. So while not at goal, we are going to make this while loop. That's why it fails directly. So let's see. If front hour is clear, it is not. If right hour is clear, then it is not as well. And then we're gonna loop here forever. Okay. So if front wasn't clear and our right is not clear, then we're gonna go and see the third case, which is LF. Right, it's not clear, so there is a wall in front. Yes, wall in front, and there is a wall on the right and wall on the right. Then we should turn on left. Okay, let's see how this would function. Okay, beautiful. So our front has a wall and our right has a wall. Let's see step by step. So we're going to skip this one. We're going to so our right is clear, so we are going to turn right like this. Okay, beautiful. Our front is clear, so we're going to move. Okay, our front is clear, so we're gonna move. So our front is not clear anymore. Our right is clear, so we are going to turn left. And then if front is clear, then going to move. If the right is clear, they're going to turn right. And it is not clear, so we are going to turn left. Then we are going to execute this set of commands. It does seem like walking. Okay, interesting. Okay, are we going to do a loop or what? I don't know. Yes, we are looping. So in this case, if this, okay, so we have to check for this in here. So our front is clear and our right is clear. So no, if our front is clear and there is a wall on the left. Okay, interesting. Let's add this if statement. So our front in here is clear. Front is clear. That is very basic. Here is the left. Okay, so front is clear and there is a wall on the right. Wall on right. Then what we are going to do is turn on left. Okay, I don't know what I'm doing actually, but we're going to test this. We are going to use this if statements here at the beginning. Easy. Just gonna make our indentation correct. Then I'm gonna name this as LF. Okay, beautiful. Let's launch this and see how does it function. Okay, so our front is clear, but there is no wall on the right. So we're gonna skip this. Our front is clear, and so we're gonna move. And here our front is clear, and there is no wall, so we're gonna skip it. I'm gonna move. And here we're going to turn left, and okay. Here we're gonna skip it. So our right is clear, so we're gonna turn right. Interesting. Oh my god, we're looping. Yes. We are indeed looping. And because of we check only for the right if it was clear. Okay. So if the right was clear and our front is clear. If there is a wall, actually a wall in front, then we are going to we're not gonna go and turn on right, we are going to turn left, actually, right? Yeah. I don't know, this is so much hard. And we're gonna add an elif statement in here. Hold on a second. Elif statement if our right is clear and our front is clear. Okay, then we are going to turn to right. Okay, turn right. Let's see how this is gonna go. Okay, let's repeat this whole thing. Start it and see. So I'm not at goal. And we're gonna see if front is clear and wall on right, then we are going to turn left. We're gonna skip it, front is clear. So we're going to move and move. Okay. So after we move in here, our front is clear and there is a wall on the right, then we are going to turn left. Interesting. So what did he do? He just spins. Interesting. Let's change this to turning to right. Let's see what's gonna happen. Okay. So we just spin. Okay, interesting. So actually we need to find a function to know which road is open for us. What's the problem? Okay. Okay, interesting. I'm going to just delete all of this. All of statements that we have made. So we're gonna check what is clear. So if front is clear, if right is clear. Interesting. I'm gonna turn right and move. Okay, if there is a wall. Okay. One front is clear, front is clear. This is not enough actually. Not enough functions. It's very hard with these little functions. Interesting. So if there is wall in front, so we're going to turn left and move. Interesting. Okay. So let's see. Front is clear. We are going to move. Hold on a second. It was at the beginning. What did we do? So we just spin, right? That's weird. So front is clear, we are going to move. Front is clear, we are going to move. Right is clear, so we're going to turn right in the move. Yes, in the move. Front is clear, we are going to move. Our right is clear. So we actually read the maze with this. So there is a wall in front and right, then we are going to turn left in the move. Okay, that's pretty neat. And we do the same, and then we have an error. Because of, what did we do? So here, there is a wall in front, in here, and a wall in right, and our left is as well not as good, so we're gonna need to turn around. To turn around is like turning left, left, and left. So it's like two lefts, left and left. We're gonna make another function called turn around. Okay. And we're gonna have two of these functions for it. I'm gonna fix the indentation. We're gonna make tab. Beautiful. So we're gonna need to check if our front is not clear, our right is not clear. Then our what is that? Our left is our left. We don't know if our left is clear or not, and that's the problem. We need this function, and we don't have it. So this is the problem, in my opinion. All in front, while on right. This is just a negation of this function, which is very stupid, right? Okay. Let's see here, turn around. Okay. Let's see how this would perform. We need a function and to know if there is a wall on left, if there is something in our left, otherwise we're not gonna get to the goal. Okay. So here we move. Our right is not clear. There is a wall in front and a wall on the right. Then we are going to turn around. Then we are going to move. Our front is not clear. Our right is not clear. Then we're going to turn around and do that forever. Okay, that's stupid. Okay, I don't know how to solve this. Because there is this direction which is the goal. And it is our left. How to know? We need another function, otherwise we're not gonna go and solve this. We need it. So let's see what do we have for the course. Okay, let's see.
Straight ahead, and finally, if it can't turn right or go straight ahead, then to turn left as a last resort. So you're gonna need to.
Okay, let's see. So let's see. The secret is to have Reebok follow along with the right edge of the maze. Turn right if it can. Going straight ahead if it can't. Turn right. Okay, let's see. Turn right if it can. Quite beautiful. Going straight ahead if it can. Turn right. Okay, let's see. I'll go on straight ahead if there is a wall on the right. So, and wall on right. So this is the secret. Actually, they're making this difficult because we are not having all the directions. If there is another function saying wall in left or left is clear, we are going to make this challenge way more easier. So turn right if it can, going straight ahead if it can turn right, or turning left as a last result. Okay, interesting. Okay. So we're going to comment out this function in here and actually do the secrets, and maybe it will work. I don't know. So we're gonna type here, should I type turn left as the last result, right? Turn left. And we're gonna need to define this as a function, call the function actually. So let's see how this would function. Okay, so front is clear and wall on right. We are going to move and turn left as the last result. Turn right if we could. Then move. Then, okay, interesting. So we're doing this mechanism. Okay. And we are in a loop. Exactly. So let's see. Up to the goal. Our front is clear and wall on right. Then we are going to move. Okay. Then turn left as a last result. That still doesn't work actually. Let's do this as well. This function, let's see what does it do. Okay, we're just gonna copy this, delete it, add a new line here, paste this, make the indentation correct. Beautiful. So how does this work? So we're going to turn right and move. And we have an error because we hit a wall. Interesting. Oh, this is way difficult than I thought. Seek is to have Reebok fall along the right edge of the maze. Turn right if it can. Okay, let's delete this move. Function from there. Turn right if it can. Going straight ahead if it can turn right. Going straight ahead if there is a wall on the right. Okay. Let's just delete this. This doesn't make any sense to delete it though. Let's see how this would function. Okay. We are looping actually. True. Let's repeat it, see. Like this is very difficult. Like for me, there is not enough functions. Okay, I'm gonna take a break. This is difficult though. Okay, so the trick in here is to make this robot turn right as much as possible, okay? If it can, so if we could actually turn right, we are going to turn right. Okay. Interesting. So, we're going to make this the first if statement we have. Okay. Okay. So this is the first if statement. These are LF. And then I'm gonna make an else statement in here. As the last result is gonna be to turn left. Okay, so and we are going to move in here as well. Okay, let's see how this functions. Okay, interesting. Let's see. Okay. No, it doesn't go as it's supposed to be. So just repeat to actually troubleshoot this. So we are actually in this case facing this direction, so we should go. If right is clear, we should turn right. Okay. Okay, interesting. So actually, if front is clear, we should actually go front. Feel me? If front is clear, go for it. Okay. Let's see this time. So the front is clear, we're not, so we're gonna turn right. So we can't turn right, so we're gonna turn left. We're going to turn left again. We're going to move. Okay, what's happened in here? If right is clear, it's not clear. If front is clear. See, oh, we need an LF in here. Okay. So, what is the difference between LF and LF? Is that if this was actually true, we skip this, okay? That's the difference. But if it was F and F, we're going to go with them both. That's not the right thing, okay? The front is clear, we're gonna skip it. LF, right is clear, we're going to turn right. And then if it was like that, okay, it seems to be all functioning just good. Okay, are we gonna loop in here? No. Okay, interesting. Let's let this go. Let's see if this functions. And troubleshoot this. Okay, so we are going to the right of the maze. But the problem here, we are going to make a loop in here, okay? Which is problematic. Okay, so at this point, we have to do something, okay? This point, our front is clear, but if our front wasn't clear, if it was our front clear, if front is clear, yeah, and this and our right is clear, okay, and right is clear, then we should turn right, okay? Turn right, and then move. I guess this is the thing that we need to add up for our code. So let's see. I hope it functions. Okay, that's good. That's not bad. So we have a problem in here actually. Just get back. Okay, in here, beautiful. So we are not at goal. Our front is clear and our right is clear. We are going to turn left. Let's add this. Let's see how it's gonna go. Okay. Interesting. Then we have to turn left actually in here. So is this gonna go in function? I don't know, I'm just, trying my best for this. Maybe it would work, who knows. Okay, here we have a problem. We turned left and we shouldn't turn left. Interesting. Let's do this, turn left again. Who knows, it might work. Like, I'm very tired about this. Okay, so it doesn't function. Okay, so this is a failure. Let's make here an LF and see what's the problem. So we're gonna turn left. Interesting. Remove this. See what's gonna happen. Still okay. Interesting. I don't know, bro. I really don't know. This is very hard. Help. Front is clear. Okay, we turn right. Right is clear. Right, else we just turn left. Then our front is clear and then we have reached the goal. But actually this is not perfect. Like, we have reached the goal, but in most of the cases it's not gonna go in function. Okay, this is the problem. Like, in this case there is a very good chance that we're not gonna reach the goal. Okay, so let's just check this out. So it's the same as before, no difference. What about this case? Okay, it's taking a little bit of time. Yes, this case functions as well. Okay, this case I don't guess it would function. Yep. So this time he is not going to the right actually. So in this case there is a problem, because our goal is to go to the right of the maze like this, and reach this place. Okay, so we're going to troubleshoot this. Okay, so we should actually turn around if our front is clear and if there is a wall in front of us. Okay, and our right is clear. Okay, let's see. Let's add this one. Okay. F wall in front. And right is clear. Then we are going to turn around. Okay, let's see what this do. Just repeat. Okay, so we read this function, we skip it. Interesting. Front is clear. Okay, I have to repeat all of this. Troubleshoot it. So, actually I have to make this here in elif. Okay, let's see. Front is clear, it is not. So we're gonna just turn left as the last result. For the front and right is clear, it's not. So wall in front is clear, so we are going to turn around. In this case, we don't want to turn around. Actually, we want to turn right. Okay. That's the only thing that we want to do. Turn right. Interesting. Let's see. This does not say anything. Okay. So we are going to the right of the maze. Okay. And solved. This seems to actually work somehow. Okay, let's see in here. So this would work. Good. In here. So the trick is to actually aim the robot to this direction, which is the right of the maze. Which seems to be functioning well. But I don't know what's the difference between this and this. Right. I don't know. The game or the development is missing a very crucial function, which is our left is clear, our left has that, so we need this direction, which is the left, and because we don't have that function, it is not optimal. Okay, so from this place it is not optimal. I don't know what's the solution of this place actually. It is very hard because we're just gonna loop this whole thing. Okay, that's the problem. You see, because we don't have the function to check if our left is empty, then we're gonna just go to the left. Okay, or something like that. Okay. Sadly, we don't have this function, so it is not optimal. So let's see her code and see what's the difference. So she checks if the right is clear, then she turns right and move. If the front is clear, then we move. And anything else, we just turn left. Okay, so there is no difference, not a big difference. Okay, interesting.
Map and robot position. So what I've done is I've created a bunch of problem worlds for you to test your code against, that we know if you use the normal code, it's definitely going to get into an infinite loop. So what you need to do is head to the course resources for this lesson and then download the zip file, which contains 3 problem worlds for you to test your code against. And then in Reborged World, you're going to click on Additional Options, Open World from File.
Okay, interesting. So we have more projects. Let's download it real quick. In downloads, Go to the terminal. I'm gonna exit from Python. I'm gonna clear CG. Just change directory to downloads. Clear. I'm gonna ls. Okay. Going to copy this. And clear, and then we're going just to do an installation. Sudo apt install. We're gonna install unrar. Okay, then just type in sudo password. Then install it because it is very lightweight, so it's very fast. So we just type unrar x. Okay, interesting. Okay, so unrar actually only for RAR files. So let's install 7-zip. Okay, 7-zip does it. Okay, we have 7-zip. Okay, let's go to the manual of 7-zip and see how we could extract. Okay, it doesn't have a manual. Okay, let's see if we could just make interesting. Okay, we're just gonna go and okay, delete blah blah blah, encrypt, store, exclude, make, add, verbose, compress, convert, chunk, move, update. So we have here compress. Interesting. You could encrypt a file as well. Compress faster. Okay, interesting. You could show the help too, formal help. Okay, let's see what we have in here. Actually, I'm gonna go and pipe this to less so I could read it. Good updates, delete, copy, rescue. Okay, all of that. Change, delete. There's a lot of parameters. Okay, interesting. So because we didn't find anything, we're gonna just grep, use this and look for extract. So it's created depending. Okay, Django removed extractor. Okay, that's weird. Let's see in SKI because it's gonna be way easier. To extracts and Ubuntu. Okay, and then we're gonna go see what we have. Okay, so it is another command. It's called 7z. That's why. So gonna clear 7z dash help, and then we're gonna pipe this to grep. Okay, double dash and then help. Okay, interesting grep. And then we're gonna need extract. Okay. Okay, just gonna clear this. Okay, here we have dash x. Include file names. Dash R benchmark. Let's show extract. Okay. Files with full path. So that is the command that we need. Clear and ls. We are going to copy this. We are going to use 7z x and then okay, so it has been decompressed. Okay, let's see. So that's weird because I don't see it anymore. To extract That's weird. I have a zip file. How to extract? Oh, so there is unzip. Okay, interesting. Okay, so we're gonna make a folder, make dir. We're gonna call this rework. And then we're gonna go and select this command, which is unzip, and then we're gonna go paste this and specify the directory. Okay, interesting. I have to specify a dash directory. And just like that, we're gonna move to that directory in ls. Then we have 3 JSON codes. It's nano into one of them. And then we have this encoding mod, etc. of the game. Pretty lightweight. Okay, that's beautiful. That's easy beautiful actually. So let's see.
And you're going to select that folder, which hopefully you've unzipped, and go through each of these problem worlds.
Okay, interesting. So we'll click on additional options. Okay, so we're gonna delete this. We're gonna use this one, go additional options, open world from file, go to reborg, and then choose the first world, then open. Okay, interesting. Then we have this maze over here, which is pretty similar to this one, right? I don't know. Okay, we could open another world. And choose world number 2. There is no difference at all. World number 3. No difference. Okay, interesting. It's the same maze, so is this a scam?
On additional options, open world from, and go through, open this up, you can close off this box, and the robot will start at a particular problem position, facing a direction that is going to cause it to go into an infinite loop. And you can know this ahead of time because when you actually go to start the robot and you hit play, when you can see the number of steps here over 1,000, it usually means that you're probably in a situation where it's going to turn into an infinite loop.
So this is actually the same maze. I don't get it. Okay. That's kind of weird, isn't it? I don't know. I'm just gonna delete this and we could make the same code again. So while not at goal, not at goal, make this column and see if right is clear. Then we are going to turn right. And we are going to move. If that wasn't the case, if front is clear, because it's the same maze, I guess, so I don't know. Then you are going to move to that direction, else we are going to turn left. That's it. Let's see. I could not analyze this error. Okay, that's weird. So what's happened? Okay, so we have here an error, and I'm not gonna use the jump function. Gonna assign to function call. Okay, so we might have here a typo. I don't see it actually. So I'm not at goal. If right is clear, turn right, move. Oh no, what's the problem here? Okay, let's see. I'm not at goal. Do this. If right is clear. Right is clear. No problem. Turn right. No problem. Ah, okay. I have here columns. That's stupid. And here as well. Okay. That was very stupid typo. I have to concentrate even more. Okay. Okay, so it does the same job. No difference at all. Okay, interesting. So, yeah, her files are useless, welche ich sagen. So, yeah. There's nothing more. Beautiful. I'm gonna get a copyright. Stop. I'm gonna get a copyright. Okay, that's fun. That's joy of the design, so just skip it a little bit. Okay, that's copyright as well. Okay, so the music is gone, finally. No copyright.
Hey, well done for completing day 6. Now, I remember back when I was learning how to windsurf, just how hard learning a new skill can be. And I think when you become an adult, this is like a really unfamiliar sensation, learning something new. Because more often than not, you're probably working in a job that you've done.
I've got rid of everything, so I have all the time in life. I have to make this work. Let's go.
For years, you've probably gotten really good at it. And you haven't actually needed to struggle to really feel the pain that you've.
That's true. If you are working in a mediocre job, getting a normal monthly salary, you are gonna get comfortable and you're not gonna challenge yourself as often, which is unhealthy.
You feel with learning. And this might be the first time you're doing that for a while. So just as when you get onto a windsurf board and you hit the water a few times really painfully, I just hit my face so many times that you feel like this is too hard. But actually the struggle is necessary. The more you struggle, the more you're learning. So don't interpret the struggle as a bad thing. It's a good thing. It means that you're making progress. So keep going, and
This is why I love this course, because you actually think and you're making your own steps and you actually suffer. You know, a good tutorial, you know what is a good tutorial when you are suffering, when you are actively learning. Not like this tutorial over here. This one, I guess. No, not this one.
And this is where
Hold on a second. Yes, this one, not this one. This one is a very trashy tutorial because he just spells terms, which is pretty useless because you're gonna need to build for yourself. And that's why this is a trashy tutorial against this one. This one's very good because you are actually learning actively, so that's the difference.
keep practicing my hat tricks.
So yeah. Interesting.
Hey guys, welcome to day 7 of 100 days of code. Now today we have a whole day dedicated to a really cool project, and what we're going to be building.
So we're gonna build another project called Hangman.
Building throughout this day is basically Hangman, or the code equivalent of this game. So the way the game works is you have to guess a word, and for every wrong letter you submit, you end up taking a life away from this little man. And of course, the longer it takes you to get to the word, the more you put your little man in danger. So this is what the final
Okay, interesting. So you have to guess a word, and if you made mistakes, that Hangman is gonna just die slowly.
completed project is going to look like. There is
This is a very cruel project because a life depends on your answers.
a random word that I have to guess,
It reminds me of Squid Game, actually.
and I'm going to type a letter to see if it's in that word. If it's not, my hangman starts and the little character starts being drawn. But if I do get a letter right, then that process pauses and the letter gets added to the word that I have to guess. And
Okay, so this is actually very easy. Let's get into the project right away. So what we have here is how to break a complex problem down into a flowchart. Okay, picking a random words and checking answers, replacing blanks with guesses, checking if the player has won, keeping track of the player's lives, improving the user experience, benefits of daily practice. So, pretty interesting. Should we go through this or just skip? Because here we are learning about a game, we are not learning about Python basics anymore. Actually, it seems to be worth it, so let's get through it.
And the goal is to be able to guess all the right letters so that eventually you figure out what the right word is. And this is an extremely, extremely difficult game. It took me many tries to get a take where I actually managed to guess the word before the hangman died. But it is quite fun. And you can check it out by simply going to this URL at the top or going over there through the
Okay, interesting. Let's go and check the demo. Okay, it's gonna be in here. Yeah, just hints. Okay, interesting. So the demo is gonna be in here. Which day is this? Hold on a second. Okay, let's see. It's day 7. Check in here, day 7. And I could delete these pretty easily. Okay, fine. So here we have the project, etc. So we could hear on the demo. Let's see. What to guess? Okay, let's type a letter, maybe A or Z. Okay, Z is strong, A, strong, G, F. So F is true. Okay, it's pretty hard. O, E, K, A, W. No, so I have lost. Okay, interesting. Let's repeat this. F. What about D? D is wrong. W. M. K. L. K. What about an E? Okay, interesting. What about an F? That's wrong. Man, these words are very hard, isn't it? What about an E, D, C, B, and H? All of them are not there. Let's try vowels. O. O. Okay. E. No. A. A, E, okay, M, L, S, okay, Isa. So there is Isa kind of thing. Isao. What is this word? D, disease. Okay, disease. Okay, interesting. Q, P, strong as well. And okay, Wolf. What is this? It was Wolf. Fuv. What is this? This is a weird word. About W in here. About E. It's true. O. False. A. E. K. V. X. and J. Nothing. It was whiskey. Ah, okay. It was whiskey. What about Q, E, O, A, E, K, M, S, okay. What about an L? Scratch. And I'm not so much good at this game. So let's develop this game actually. It's pretty hard. So yeah. Let's go to the next video. So in this video we are going to learn how to break a complex problem. So a flow chart.
Alright guys, so before we get started with our project, it's really important that we're all on the same page and we understand how the code is going to work because we know how the game works. So I recommend that if you've never heard of this game, Hangman, then before you continue to just head over to the Wikipedia article on Hangman, and it might be even easier if you select your own language because I know that it has a different name in different languages. Now, if you've never played this game, I also recommend just to go and give it a go online. So I'll link to this address, and if you click on single player untimed, you can see that you have a word that you have to guess, and then you start picking some letters, and if it's right, then it goes in, and if it's wrong, then the hangman gallows start being drawn, and our little man is at risk of being hung. Once you understand how the game works, it's time for us to examine what the logic for our program is going to look like. And to do that,
Okay, that's interesting.
we're going to use flowchart programming. So it's very simple. It just means that we can draw out a flowchart to represent the logic of our game. At this point, I want you to pause the video and have a quick think about how you would program Hangman. Try and come up with a flowchart that represents the logic of this game. Break it down into little steps. What needs to happen first? What needs to happen when the user makes a guess? And what should happen when the guess is incorrect? When should the game end? Pause the video.
Okay, that's interesting. So if we saw the demo, it's pretty easy. We print this, and then we print an input. Then we are updating that input. Then if one of the letters matches the word that we have in our list, then we are going to update the prints, then we are, and so on and so on until you finish. If you want, then we are going to print yes, you won. It was scratch, so the word is scratch, you win. If you lost, we print this. Okay. And then we print this as well. So we are going to update our prints with time to our output to the user. It looks pretty easy. Very simple. We're gonna do this after I take a break. So yeah. We're back. So, yeah, we're gonna need to fix the chart. I need to pause the video and check one of these resources, I guess. So here we have the wiki of the Hangman. And who knows? Okay, it's interesting. Here we have a flow chart. Okay, could zoom at it, so it would have to generate a random word, then generate as many blank letters in the word, so the same length of the word. Generate blank letters, ask the user to guess a letter. Then we're gonna have loop in here. If you lost a life, then they have run out of their lives, etc., etc. Okay, it's interesting. Okay, so here we see the same flow charts being made, etc.
Letter act.
Okay, so I do understand how this should work.
Only
And if he lost, then we are going to minimize one of his lives, etc. Okay. So here we're gonna work for the first step of this game. Open PyCharm. Then this is the demo. We had the first to do, which is randomly choose a word from the word list and assign it to a variable called chosen word, then print it. So first we're gonna have to import random. Okay, then we're gonna have to choose words. Then we're gonna check random choice from the list exactly. Then here we have to ask the user a letter and assign their answer to a variable called guess. So we would have to ask the user to guess a letter and assign their answer to a variable called guess. Okay, so here we're gonna need to make a guess variable. Then here we're gonna just do an input, guess a letter. That's exactly what it's supposed to be. Make the string stored and the guess and should be lowercase, so here lower exactly. And then it's gonna be stored in this variable. It's pretty interesting. To do 3, check if the letter the user guess and this variable is one of the letters in the chosen word. Loop, so we have to do loop through each of the letters in the chosen word and print right if the letter is a match, wrong if it's not. So we're gonna do a loop. So we're gonna loop in 2 cases. So while we're gonna loop for letter or for word and word list. Okay, if the guess is equivalent to the word, right? Then we are going to return true. Something like this, I guess. I don't know. Let's take the hints. Through each of the letters and the chosen one and print right. Okay. If it's a match, wrong. If it's not. Okay, we're gonna need to print and not return. So print. True. And we're gonna need to do an else in here. Else we're going to print false. Okay. So the problem in here, okay. That's interesting. So this first of all prints this variable, and we're gonna need to comment out all of this. Hold on a second. Oh my god. I'm just gonna leave it as is and print this. Okay, interesting. It seems that we truly choose a random word. I'm gonna choose a false, false, false. I don't know how to do this actually. It's actually pretty difficult, isn't it? Okay. It's interesting. That is actually very interesting. So there is a string in here. Oh my goodness. Oh my goodness. Oh my goodness. How to do this? So this one is done. This one is done. But the third to do is very difficult. So let's see a hint. You can loop through strings the same way we can loop through lists by using the for and loop. So I went through strings Python. Okay. Okay, that's interesting. Okay, so let's ask AI how to loop through string in Python, and how to compare if the... Okay, we're gonna leave that for later. A lot of codes, crazy. Okay, so here we have my string equals hello. So for character and my string print car. Okay, interesting. So here we do understand that we are looping through each letter. Oh, okay. Okay, that's very interesting. Now that we have this sample, guess it's very easy to troubleshoot this right now. So just remove this thing from here. Okay, so for each character in Word, we are going to compare our guess. So if guess if character is equivalent to the guess, then we are going to print where is she? Yeah, I'm gonna print true. Otherwise, yeah, we're gonna print this boolean. Else, which is otherwise, we are going to print false. Okay, let's see. Guess a letter, choose B. So we have true, false, and false. That's good to know. Okay. So check if the letter the user guessed and the guess is one of the letters in the chosen word. Loop through each of the letters in the chosen word. Okay, interesting. That's very interesting. So here we're gonna make a correct variable, I guess. It's gonna be an empty string. Okay. And if it was true, then we are correct guess here. Correct guess. If that was true, then we are gonna take this correct guess and add it up to the char. Okay. Okay, that's interesting. Okay, let's see how this would work. Here we should guess a letter about A, then false, etc. Okay. Else. Okay, that's interesting. And here we are gonna make another variable called wrong guess, and it's gonna be an empty string. Okay, so here we're gonna make our variable. Okay, here it's not defined because of this syntax error. Wrong guess, and then we're gonna add it to the char. And then as a result, I'm going to print correct guess and wrong guess. Let's see. So here we have A. So yes, here we have guessed A in here, another A, and so we have 3 A's, and we have guessed all of them. And we have guessed, and we didn't guess R, D, V, and RK. Okay, that's interesting. Okay, here we could use a for loop, etc. If you need to know the index position of the character as you loop, you can use range line strength. Char my string. Index 0 H, index 1 E, index 2 L. So we're gonna need to use this as well. So for each index in range of this, then okay. Interesting. Char, okay. Could use here enumerate as well. Enumerate function is a Pythonic way to get both the index and the item during iteration. Interesting. So here we get the index of the item and the character as well. So for the first index, which is 0, we have H. Second index, we have E, etc. So I think if we went to PyCharm, we have done the third almost. So yeah, what we should do in the third one, check if the letter the user guess is one of the letters in the chosen word. Loop through each of the letters in the chosen word and print right if the letter is a match, print wrong if it's not. So here we don't have to do a lot, already need to know if if this character was equivalent to this only, then we could print that was right, else we would print that was wrong. Okay, actually I feel I could develop this Python thing. Okay, maybe I could transform. Let me just delete this to do. It's a little bit annoying because this is a very simple project, so I guess we could do a lot of damage to it. So here we're going to get a random word from our list, and here we're gonna input a guess letter, and I'm going to transform this guess into a list. Okay, I'm gonna make here some spaces. Interesting. And I'm going to transform this variable, which is word, as well as a list, and I'm going to work with lists, and I'm going to employ this enumerate mechanism to get the index as well. So let's get that done. Okay, so we have two lists right now. Interesting. But before that, I'm just gonna go and ask AI how could I comment out multiple lines in PyCharm. So I'm gonna go and actually develop this whole project. Okay. Control indent. Select the line of code you want to comment out and then press this shortcut. Okay, interesting. Let's see if that functions. Let me choose PyCharm, choose all of these in here. Yes, it functions as butter. Okay, interesting. So we're gonna get back to here, go to the enumerate, and we're gonna employ it. Okay. So I'm going to print guess, and I'm going to print word. Okay, and let's run this. So we're gonna guess the letter A. Interesting. So the guess is A. Okay. Okay, that's interesting. Let's delete these. Let's print the word list. See how that looks like. Yeah. Okay, so let's ask the AI how to convert a variable into a list, a string variable to a list. Beautiful. Okay, so could use this. Okay, so we should. Okay, that's why. Interesting. Okay, so I'm a little bit tired, but it's alright, we could do it. So we have here the word list, etc. So we should make here another word. So we're gonna call it random word list. Beautiful. And we are going to assign this to the word that we have chosen as random. Yeah. And then here we're gonna add guest list. And then just like this. Beautiful. Okay, so we are going to print this in this. Exactly. And then we are going to print guest list exactly. Let's see how that would look like. Let's print here A. Okay, beautiful. So they all right now are string lists. Beautiful. Okay. Okay, so I'm gonna just launch this loop again. Yeah, I'm gonna delete all of this and all of this as well, and then we're gonna use the enumerate and just see where it is at, like that. Okay, so okay, let's see. So we're gonna define an index and char. So we're gonna define two variables while we are enumerating the string, which is it's gonna be a random word list. Okay, beautiful. So okay, so f our char, which is the character in this random list, if it was matching our guess, okay, then oh, look at this random word list index. So we're gonna take the index in that list. Okay, so we're taking that index and then we are replacing it in the guest list. Okay, let's see how this looks like. I'm gonna print right now the guest list. Oh yeah, yes, let's print them again, all of them. True. Let's see, here we are inputting A. So random word list, we have CAMEL, and here we have A and CA. Okay, MEL, and then here we have A. Oh my god, it's very difficult. What a freaking headache. I'm gonna take another break and try to follow the tutorial. This seems to be a very complicated project, and yeah, that's it. I don't want to cheat with AI because that would not be called as learning. Yeah, that's my goal. Okay, so let's continue. Okay, so let's see what's happened in this course. What should you do? She imported the random choice. She chosen a random word. That's pretty obvious. Very easy to do. Then she printed that word. Okay. And then she asked for an input. Guess letter dot lower. Exactly. That is actually very obvious. And then here she makes a for loop, letter and chosen word. Okay, interesting. And then she prints letter. So she just iterates through those letters. Pretty interesting. So if letter equivalent to our guess, then I'm going to print true, else wrong. Okay, so we have made this third to-do list. Okay, and that's actually pretty enough. So I was actually trying to get the project done with help of AI, but it is actually a very, very hard project. So yeah, so I'm just gonna go and do simple stuff. So here are the first to-do lists, and then we're gonna do a for letter and gonna make this chosen word. Okay, like her. So chosen word, and then we make a column. So if letter equivalent to that, we are going to print true or right. Okay, interesting. And we're gonna make an else statement. We're gonna print wrong like that. Exactly. And then I'm gonna run these commands. I'm gonna press A. Then we have guessed it correct. Okay, so for this video we are done. I'm gonna go to the next one. Okay, let's do it.
So now it's time to move on to step 2 in the 5 steps to create our hangman game. Now in step 2, I recommend reading through the description for a...
Okay, so let's try to do this ourselves, and then we're gonna go and see if we have made a mistake, etc. So we're gonna go to second step, and then we have for the first to do, we should create an empty string called placeholder, and for each letter in the chosen word add a underscore to placeholder. Okay, so let's create this placeholder right over here. I'm gonna call this placeholder, and it is an empty string, right? Yes. And for each letter in the chosen words, okay, add an underscore to the placeholder. Okay, so for character and chosen word, we are going to add placeholder. We're going to add placeholder plus a string, which is an underscore. Okay, that's done. So if the chosen word was apple, placeholder should be with that amount of letters. Okay, representing each letter to guess, and then we are going to print out hint. What do you mean by hint? We should print out the hint or what? I don't know. Okay, so let's print the placeholder. We are going to comment out this for the moment, so like that. And we have an error in here. Okay, beautiful. Let's run this, and then the word is baboon, which is A. So the placeholder is ready, which is beautiful. So to do number 2, create an empty string called display. Okay, I'm gonna do that. Okay, display, there's equivalent to an empty string. Okay, loop through each letter and the chosen word. So for letter and chosen word, okay, or character, chosen word, okay, character, so that we just stick with our pattern. Okay, look through each letter and the chosen word. If the letter at the position matches guess, okay, so I'm gonna need an index and a character, okay, because I'm gonna go and loop through the position as well. Matches guess, then reveal that letter in the display at the position. Okay, interesting. How to do this? For example, if the user guessed P and the chosen word was apple, and then display should be like there. Okay, so we're gonna use that placeholder as well. Okay, interesting. There is a technique we could make a list for the placeholder. So placeholder dash list underscore list, and that is the lists function of the placeholder exactly. Okay, so we're going to enumerate this, yeah, choose the word exactly. Then we're gonna go to our AI, we're gonna go and get inspired from this pattern in here. So here's the index and here's the character. Oh my god, it's difficult. Let's get this done. Index 0 we have H, index 1 we have E, etc. So how to do this? Let's make another to do in here so that I know what I'm gonna do. Okay, to do. So what should I do in here is let me think about it. So a chosen word could be something like this, AAA, etc. Placeholder is gonna go and take those as underscores, okay. Something like this is gonna be that placeholder. That placeholder is a list, so beautiful. And then we're gonna get the index of A, etc. If it does match, which means if the letter or if the char, so here if the char matches the guess that we have made, then we're gonna go and check the display. Okay, what is this? Equals -f. What is this syntax? So this is the AI that makes that for me, integrated in Python, which is weird. Okay, interesting. I don't know what this actually does, so we're just gonna print it. Okay, so we're gonna print display exactly. I'm gonna test what this syntax does. Okay, so this doesn't do anything. to the display, just adds it. So yeah, we don't want to use that syntax. Okay, beautiful. So what we should do right now, so the letter is equivalent to that. We are going to replace the index that exists in the placeholder. Okay. Interesting. Could make an underscore. Then we could add that. I have an idea. So if the chart doesn't match the guess, then we could actually add an underscore to display. Okay. Let's see if that functions. Else we're gonna add display. We're gonna add to it the character. Let's see what that does. And print A. That doesn't do anything. No, we should print display so we could troubleshoot that. About A. Yes, it functions like butter. I told you. That's crazy good. Okay, so for this reason, let's see if we have made this studio. The third one, or the second one actually. Create an empty string called display, loop through each letter in chosen word, which is true. Okay, so actually we won't use this enumerate. It's a little bit unnecessary. And we're not gonna use the index as well. I'm gonna use char. Okay, loop through each letter in the chosen word. Okay, if the letter at that position matches guess, then reveal that letter in the display at that position. For example, if the guess, so yeah, that's true. Print display, you should see the guess letter in the correct position. That's true, right over here, camel. With every letter that is not matched is represented with an underscore. So actually we're not gonna need a placeholder. So all of this code is unnecessary. Okay, we're gonna need the display as an empty string. We're gonna need a for loop that loops through the characters in the chosen word. Then we're gonna need an if and an else statement to catch two cases. If that character matches, if it doesn't match, then we're gonna just add an underscore. If it does match, then we're gonna add that character, that placement. Okay, that functions like butter. Okay, beautiful. So we're not gonna need this. No placeholder. Just unnecessary. Okay, this code is enough. Okay, so let's go to the next step. Okay, so for the first to do, use a while loop. So what she did in this code in here. Okay, she made chosen word equals random. She chosen a word, she printed it. She made a placeholder and she made a word length equals the length of that chosen word. Then for position and range, we're gonna add to that placeholder underscore. Okay. Then we're gonna print the placeholder. Okay, this is unnecessary. If the letter matches, then we're gonna add the letter, else we're gonna add an underscore. Okay, interesting. So we do share the same type of for loop. Okay. Okay, I'm just gonna get back. Could I reverse what I did? Yes. So for me, I have just used a very basic for loop, and I've used I used what do you call it? I looped through each letter in the chosen word, okay, and added underscore to the placeholder, which is very enough. Okay, so I'm just gonna take this, go to the third, and I'm gonna go and replace all of this. Look at my code, it has like 3 lines. It's very economic rather than her code, which is unnecessary. Then for the display, we do share the same type of code. I have used char rather than letter. Okay, beautiful. So we do share some similarities. So here, and to do one, use the while loop to let the user guess again. Okay. The loop should only stop once the user has guessed all the letters in the chosen word. Okay. Okay, so I'm gonna make a while loop in here just for testing. So while the display doesn't equal this string placeholder. Okay, interesting. I'm not gonna use that. The placeholder is gonna be has no more blanks if the display has no more blanks. Doesn't have more underscore. Okay. Okay, beautiful. And then we're gonna go and start from here. I'm gonna ask the guest to give us a guess, and then with that guess we're gonna just do okay, we're gonna copy from here and do this for loop. Hold on a second. Okay, and then we're gonna add to that display the chosen word, all of that we have made it previously. Okay, beautiful. Okay, we could actually just comment out all of this. Display, gonna copy this, delete it, and paste it in here. Okay, beautiful. Here we have this is gonna be commented out. This placeholder, I'm gonna comment it out as well. Okay, interesting. Okay, so this is enough. Let's test this out. So we're gonna type here A. Okay, here we have a problem because we have to print the display. Let's run it again. A. Okay, and T. Oh, look at this. There is a problem in here. Interesting. This is kind of difficult. Okay, let's see the course. How we could troubleshoot the third step. Maybe we're gonna get an idea from it. Okay, see this second step, pretty easy. Okay, we're gonna skip it and go to the third step.
All right, so now that we've reached step 3, we are moving onwards and upwards. And we're going to add a little bit more functionality to our Hangman game so that it functions more and more like a real game. So in this particular step, we're going to add the ability for the user to continue guessing again and again, repeating the Hangman.
Okay, so this is a nice functionality, but the problem is that we are adding this repetitively, which is not healthy. Like if we could actually add it only once, then and replace it and have much more flexibility, then it's way better. Otherwise, we're just gonna add underscores and that's not gonna be perfect. Okay. So maybe for that case, we are going to use the placeholder. So rather than adding underscores to the display, maybe, I don't know. Actually, I don't know how to do this. It's pretty hard.
hang checks until they get all the letters in the word. So if you go ahead and right click on solution.py and then run that solution, we can see what the end result of this step will look like. So we have the chosen word, we have the number of characters in that word, and then we are asked to guess a letter. So if I start from the beginning and I guess C, now what we want to happen is this. We're getting another opportunity to guess, and we want this to repeat by writing a while loop in our code. So that's to do number 1. Now the next thing we want to do is to update this for loop here so that if we guess a previous correct letter, such as the C in this case, when we guess another letter correctly, we want to keep the previous correct guess and the new letter and add all of that to our variable called display.
Okay, that's interesting. Interesting. The question how to do it, okay. That's the problem. How? That's actually problematic. Let's replace this with a placeholder. Maybe that's why we made it. And then display, we have to update this display in order to keep the older guess that we have made. And what how to do it actually is the question. Okay. So we're gonna loop through these letters, and if the letter is equivalent to that, we're gonna add it to the letter. Otherwise, we're gonna add an underscore. That's the thing that happens. Let's see the hints. We can't do that, so we don't have any hints in the moment. It's interesting. Okay, use a while loop to let the user guess again. The loop should only stop once the user has guessed all letters in the chosen word. At that point, display has no more blanks. Then you can tell the user they've won. Okay, interesting. The problem, how to update that display. We should make some Googling or AI. So let's ask him. We have this update. I'm gonna copy the whole while loop. I'm gonna ask AI how to update the display string so that the underscore for the wrong letter stays and the correct letter gets updated, and for the next guess the older display update stays and the of the older display update of the correct letter stays and the underscore stays the same as the length of the chosen word. Okay. Okay, and if we have if we have guessed all the letters, the while loop breaks. I have myself made the condition, which is the placeholder, who has the underscore for the chosen words previously. Okay, then I'm gonna paste this and see how this is gonna function. Okay, so this is a classic problem from a hangman style game, correct? The core issue in your current logic is that you are rebuilding the entire display string from scratch. Yes, that's my problem in every iteration, which overrides previous correct guesses. So to fix this, you need to iterate through the current display string and the chosen words simultaneously. Okay, interesting. And only update the characters in display if the user's guess matches the corresponding letter in chosen word. Okay, so we have a chosen word, which is Python. And this is initializes display, which is all of them are underscore. Okay, print words display. So while underscore in display, oh, this is way better. This is a way better condition actually. So if there is an underscore in display, we are gonna still gonna execute this while loop. Otherwise, we're gonna break it. This is a way better condition. I really do like it. Okay, let's see what we could do more. Okay, guess equals inputs. So here we take the guess. Then we create a new display string based on the old display and the new guess. So here we have a new display. Interesting. And the new guess. So each time we make a new display kind of thing. And here we iterate through the chosen word and the current display at the same time. Okay, so for each index in range length of the chosen word, check if the letter has already been revealed. Okay, so here if the display and this index is not equivalent to an underscore, we're gonna add this index to the display. Okay, so this is a little bit complicated. I'm not gonna follow this. It's gonna be way better if we saw the solution in the course.
Now, in contrast, let's take a look what happens at the moment if we use our current state of our code in main.py. So if I guess A and all the A's in aardvark gets filled in, the next time that I guess this word, my previous ones will be lost because I'm again checking against the current guess. So think about how you might solve that, and it
Let's just repeat this.
happens at the moment if we use our narrator and add all of that to our variable called display. Now, in contrast, let's take a look what happens at the moment if we use our current state of our code in main.py. So if I guess A and all the A's in aardvark gets filled in,
Yeah, all of them gets revealed, which is a problematic.
the next time that I guess this word, my previous ones will be lost because I'm again checking against the current guess. So think about how you might solve that, and if you get stuck, there's always hints in the description box for you. But there is quite a bit of thinking and quite a bit of struggling in.
Yes, there's a lot of struggling, so we're just gonna forget what the AI has given us. We're gonna try to restart this program because I cannot access the hints, which is unfair. So, don't ask again, exit, terminate, beautiful. We're just gonna look for PyCharm, execute it. We could pin this to the task manager. Okay, beautiful. Okay, interesting. So here we have everything restored. Okay, beautiful. Okay, so let's work on this. So each time we're going to make a new guess and a new letter. I'm gonna input that, that's correct. So for let's just change this to character because it's just way better. Yeah. Okay, beautiful. So let's see what we could do in here. Okay, let's see. For character and chosen word. Okay. If the character is equivalent, then we're gonna add it to the display. Okay, but we need more than one display variable. So let's make like the AI set new display. That's gonna be practical. And it's gonna be an empty string as well. So for each character in the chosen word, we are going to we are going to guess. If this is correct, then we're gonna add it to the display. Else, I'm gonna add an underscore to the display as well. Okay. I don't know, this is so freaking complicated. My head. So you see the hints? Okay, it works. You can use the N keyword to check if a string or list contains a particular item. You can use the in keyword to check if a string or list contains a particular item. Check if a letter is present in a string. Python, okay. It's actually in for this loop. That's interesting. Oh, maybe we could make another if statement. If I don't know, maybe if a character is in display, then we could maybe add it to the new character, maybe. So maybe this line of code would do something. Okay, let's do it in here. Beautiful. Okay, so let's see. I'm gonna make some spaces for me to think about it. Okay, so what this does is that if this character is already in the older guess, then we are going to add it to the new guess and check this out. And if the new guess that we have made, okay, hold on a second. This is only a while loop, so we're gonna do this all the time, right? It's problematic. This is really problematic, you know what I mean? So we catch this case. Okay. Okay, let's print let's print display and let's print new display and see, because I really don't know how this is gonna go. So let's execute this. When do we have an error? Name is not defined, so maybe you can't just do that. Because outside of the while loop, right? Interesting. Okay, so we have some problems in here. Even I cannot even. This is annoying. It's actually indeed annoying. So print the new display and then print the display as well. Remove this. Let's see how it's gonna function. Okay. Okay, what happened in here? Why did it execute like this? Interesting. Why don't we execute this, the while loop? Interesting. Could make actually here placeholder. That's the while loop works, right? Okay, so okay, that's problematic. This is very problematic, actually. We could maybe use this old guess mechanism, and we could actually get rid of this. Okay, we could make this an empty string. Could copy this and paste it in here. Change the for loop so that you can keep the PS correct letters in display. Okay, let's see how this is gonna go. Choose here B. Okay, beautiful. Interesting. Is not in. Maybe. Okay, C. A. Okay, interesting. Interesting. I don't know how to do this actually. I'm gonna take a break, made a research with AI, something that is less of a cheat, then we're gonna see how this is gonna go. We're back, we're back, we're back. We never give up, in it. So right now, after I have learned how to do a lot of things, I have to divide this problem, which is let me write the problem. So what's my problem? Okay, the problem is I want to update the display variable into the right guess in the right index. Okay, index of the placeholder of the chosen word. Okay, I'm just gonna make a new line in here. Beautiful. And what I want as well is I want to update the display variable into the right guess. What do I mean by this? Into the right index of the placeholder. Well, I mean by this, first right guess, I'm going to have underscore a underscore. Okay. And for the second guess, so I have to divide this problem. This is the trick. Okay, I'm going to keep this a, and if I made a second right guess, I might have a b in here. Okay, and for the third guess, right guess, if it wasn't right, then we're gonna just keep this as is. Okay, so for the third guess, I'm gonna have a c, for example, in the b, and then 2 underscores a, etc. So this is the pattern that I'm wanting to follow. Okay, so I'm going to replace so there is a original word in here as well, which is chosen word, and it's gonna be CBADAL, for example, speedal. And this is the chosen word exactly that I'm working at, speedal, and this is the guess of it. Then we have a placeholder, okay, which is all underscores. So we have here 3 and 3 letters, 3 and other 3 letters. Beautiful. This is placeholder, first guess, second guess, third guess. Okay, so this is the pattern that I'm wanting to follow. So the chosen word is ready in here, and it's being printed as well. The placeholder is ready, and it is in here. So this one is done. Okay, done. And this one is done as well. So the first guess I have made, which is as well done, which is in here. So you made your first guess, and the display is being it's being updated in the right manner. Okay, let me just recover that. Beautiful. So the first guess is done. So the problem is in here, which is how to not do this output, how to not output this. Okay, I'm gonna make that, just hold on a second. I'm going to comment this out. Okay, so let's do this. I'm gonna go type A. Okay, that's problematic. It is problematic. I'm going to comment out all of this. I'm going to play with this. A. Okay. Maybe another words. I do I choose that word all the time? So let me choose, for example, N. Then it does it just right. Okay. Okay, so I'm going to uncomment this and C. And okay. That's interesting. So I'm gonna make this something like that so that we could hold on a second. See here we have baboon, correct. We have an N. Then we have B. Then we have an O. Then we have B. Then we have B. This never stops, isn't it? That's problematic. Oh my god. Oh my god. Oh my god. Okay, so I have to troubleshoot this. So I'm going to repeat all of this, okay? I'm gonna go delete all this. Okay, so we're going to make another guess. Built from this, okay? So we're just gonna make it real quick. Then we're gonna prompt B in here. Okay, so the while loop is working. Okay, beautiful. Okay, let's see what we could do. Choose a word, for example, placeholder. So to actually make this done is through some kind of syntax that I don't know about. Okay, so we are going to make a for loop. I'm going to iterate through this chosen word. Interesting. Interesting. I have an idea, which is to use an indexing char and use enumerates. Chosen word. Okay. If the char is equivalent to the guess, then we are going to take two type of input and replace it in the display kind of thing. So maybe we're gonna make display list like that. Display lists, and I'm going to list display. Then I'm going to take the index of the display list, yes. I'm gonna replace it with the index and then replace it with the correct character. Okay. Okay, interesting. Then we're gonna repeat all of this all the time. Okay, let's see how this is gonna be. So we're gonna print this list and see what's gonna happen. Just gonna go make it in here. Okay, Let's see. Type B, type A. Okay, so it worked. Oh, interesting. So we have here B, we have here an A, then we have B, a B, and then 3 underscores. So this works. Beautiful. Okay. So we are replacing the character with the right index. Okay, interesting. Interesting. Okay, so maybe I could comment out this for the moment. And we have here the display, etc. I could comment out all of this. And maybe I'm just gonna go and add that display. I'm gonna comment out the, okay, like that. And I'm going to to define display. Display. It's gonna be equivalent to the placeholder. Beautiful. So while okay, interesting. So this should function. Let's see, maybe. So we have a C in here. C has been replaced. Then we have an A. Beautiful. This functions like butter. An E. Then we have an L. And we have guessed everything. Okay. And then we have to update the display with the list. Okay. After we are done. Okay, let's do this. Okay, so we have a list which is updating each time. So maybe I could use the display, the join method, which is equivalent to an empty string. Yes, the join, yeah. I think this should do it. Let's see. So B, beautiful, A, beautiful, O, and we have N. Okay, so the while loop has been broken, which is great. We could print the display as well, so we see if everything works fine. So we have here B, yes, an A, yes, an N, yes, an O, yes. So this functions, but we are actually displaying 2 letters, which is not as good as it's supposed to be. So I could replace only 1 letter. Okay. So if the character is equivalent to that guess, then we're gonna go and take that index and replace it with the character. So this happens twice, and 3rd time. Interesting. Interesting. I don't know, what should I do to fix this? So the problem is I should fix this. So what I know right now is that I have used very much less lines of code, so I'm just gonna delete all of this that I don't need. Okay. So we are 1 step forward. The problem is that we don't want to replace 2 characters at the same time. Okay. And to do this, we will need to limit the amount of assignment that we do in here. Interesting. Because we are enumerating for the indexes and the character at the same time, and that character is repeating. Okay, that's the problem. Let's see the tutorial, because, or let's ask AI. Let's say I'm using this for method, for loop method, and Okay, I have made my own method and I assign to each index that right character in the display list. Then I convert it to a string, then convert that list to a string variable. But the problem is that if the guest letter repeats twice in the guest display, and that reveals 2 characters. So my question is how to limit that this assignment is correct. This okay, let's go to the PyCharm and just copy this one. It's assignments. Okay, just get back, paste this. How to limit this assignment to only one index and the display list. So this is the only problem, is that I don't want to replace 2 indexes in this list, only one index, because I'm using an if loop, for loop for that. So yeah, let's see. Okay, we have a chosen word, which is banana, display list, line chosen word, etc. Guess equals a example guess. Check if the entire words for all concurrence of the guess for index in range line. If a char equals a chosen word, if char equivalent to this line correctly reveals all matching positions in this turn. Yes, after the loop, display list will be a. Convert back to string for display if needed. While limiting to one index is usually wrong. If you limit the assignment to only one index, you would need extra logic to track which indices have already been revealed, which makes the code much more complex than simply checking against the chosen word every time. For example, if the word is apple and you guess P, if you limit to one index, the display might become if it finds the first P and stops checking, the second P remains hidden, which is incorrect. If you check only on this, I'm asking AI to help me and he says no, your way for doing it is recommended. Oh my god, I just hate you. So, and this is the recommended way the display becomes I want to limit for one index, so the next guess could be made for the next index. Okay, how to limit it at the first guess, and then at the second guess, how to skip the first revealed index and reveal the next index. Okay, let's see. Okay, I understand. Now you want to reveal only one letter per correct guess, even if that letter appears multiple times, and you want the subsequent correct guesses to reveal the next unseen instance of that letter. This means you need to keep track of which indices in the chosen word have already been revealed to avoid revealing them again prematurely. Okay, so logic to reveal only one index per correct guess. So the chosen word, the word to guess, display list, the list representing what the user sees with underscore. A set to store the indices that have been already successfully guessed and displayed. Okay, so here we have a chosen, so we're gonna add this variable, which is pretty nice. So here we have chosen word equals banana, display list, which is this, reveal indices, set to store indices that are already shown. Okay, interesting. Okay, here initial display, so we are making that display. Guess equals A. Find the first index that matches the guess and has been revealed yet. Found new reveal equals false. For index in range, check if the matches guess and if the index hasn't been revealed before. So if chosen word index equals guess and index not in revealed indices. Oh, interesting. So we're gonna make this one a set. I don't know what this function, so I'm gonna make AI to explain it. So we're gonna use this variable. Then we're going to use this if statement. This is the new thing that we have, and we have this one as well. Found new reveal equals false. Okay, see here we have display lists of the angles. Okay, interesting. So here we replace it, and then recall this index as revealed. Okay, and then we have a record, so we have a database for this. Reveal indices dot add, and we add that index. Find new reveal, and then we make it true. Print correct guess, etc. Okay, and then we are breaking. So for our case, we are not going to break. Interesting. After the term prints, blah blah blah. Okay, so we're going to use this set. And we are going to keep track of those and see how we are going to make this happen. So we are going to make a set. We are going to add this one as well. Found new reveal. I'm going to set it to false, and then we're going to add to our if statement. So for index, etc. So here's our if statement. If chosen word index equivalent to guess. If char equivalent to guess, okay. And index not in revealed indices, then we're going to add this. Okay. And then we're gonna, okay, interesting. I'm just gonna copy this one. Not in reveal indices. Okay, interesting. And we're going to input this over here, this if statement, paste it. So here we have chosen word dot index. Okay, we have here a problem because we have double F statements, which is not right. Okay, then we are going to add that index to the display list. And then we are going to record the index that has been added. Interesting. Okay, it needs some spaces over here. Yeah, so we're going to record this. Needs some space in here. We're gonna add this index to our sets database, I guess. Seems to be like a database. And then we are going to change this found new reveal to true. Okay, let's see. Beautiful. Okay, let's see if this functions or is it not. So I'm gonna add B. No, it doesn't. Okay. I guess. There is no need to do this, but it doesn't work. Yeah. Doesn't work. So why doesn't it work? What does this reveal? So there is a lot of stuff that I'm not understanding, so I'm just gonna go and reverse all of this. Okay. I'm going to reverse all of this. Beautiful. So for the moment, I guess I have made the first to do. And here we have the second to do. Update the loop for loop so that previous guesses are added to the display string. At the moment when the user makes a new guess, the previous guess gets replaced by we need to fix that by updating the for loop. Okay. Think about how you can store the matched letters and even LF. So the letter has been matched before. Okay, interesting. So I have used this method of using the index and the char and trying to just update that index by itself inside of the list rather than using a normal variable string. It seems to be enough for the third step. Okay, so I guess my code is enough for the third step. Let's go to the fourth step. And here we have the game. So create a variable called lives to keep track of the number of lives left. Set lives to equal 6. Okay, interesting. So she uses her code in here. For letter and chosen words, display, post letter, code letters that appends. Okay. So she makes here a list called correct letters. Okay. For letter and chosen word, if letter is equivalent to that guess, we're going to add it to the display. And we are going to append that guess to the correct letters. LF, letter incorrect letters, display, plus that letter. Else, display. Interesting. This is very interesting code, but it is unnecessary. For that, let me just see how does it perform. Is it better? No, it's the same as my code, so that's a very good plus sign. So let me just copy my codes in here. Copy all of this. And then paste it in here. Okay, if not in display, game over equals true, prints you win. Okay, guys, I'm just gonna place it in here. Beautiful. I'll delete this one. And that's it. Okay, I'm gonna go and delete this import because we have it on top of the screen of the script. Okay, beautiful. So our first to do, create a variable called lives. Okay, let's create it. So here I'm just gonna go and input all the variables that we are going to make. Okay, here we have a placeholder. Okay, we need a variable called lives. It's gonna be equivalent to 6. So we're gonna have 6 lives. And for character and chosen word, placeholder. Okay. So the first to do is a while loop to let the user guess again. Okay. So I'm gonna add an or gonna add an or. I'm gonna say if lives equivalent to 0, then we are going to we are going to break the while loop because this is a game over or this is a winning. Okay. That's interesting. Okay, so first to do is a while loop to let the user guess again. That is done. So this is pretty old. So the first to do, create a variable called lives to keep track of the number of lives. It's okay, so that is done, so I'm gonna delete it. And here to do too, if a guess is not, if the guess is not a letter in the chosen word, okay, then reduce lives by 1. Oh, interesting. Okay. So here we're gonna make another if statement. I'm gonna need some spaces in here. Okay, so if the char, so if the guess, interesting. So here what we do is that if we didn't append anything, then okay, that's interesting. Because here we are looking for the characters and seeing if that guess is in there. If it is, then we do that. Otherwise, we are going to see if this functions. Otherwise, if it doesn't function, if the guess maybe we could make an else statement. Maybe that will do it, would catch the other case, because we have only 2 cases: append or you're going to lose append to the display list, or you're going to lose your life. So maybe you could do that. So I'm gonna make an else statement in here. Okay, I'm going to make it not in here but in here. Yes, in here. So the second case is gonna be to take the lives and minus it by 1. Exactly. So why is this wrong? I don't know. Oh, interesting. I would put it in there. Okay, so like that. Okay, beautiful. This is actually functioning as it's supposed to be. Let's test it out and see. Guess a letter. Let me just print the chosen word so that I could troubleshoot this. Print the chosen word, exactly. Let's test this again. It's gonna be A. Okay. Okay, so if we have lost a life, we're going to print lives. Okay. So let's repeat this. Let's choose a letter that doesn't exist, maybe L. Okay. Oh, look at this. Oh, interesting. Interesting. We are actually, okay. Interesting. I'm gonna need to think about this. My brain. Take a break and then I'm gonna come back to troubleshoot this as well. So I have an idea. I want to actually divide this problem. So I'm just gonna go over here, copy this code, copy it, then go to AI and say, okay. So looking at this, we are having okay. So if we have enumerated through the whole characters and chosen words, and we did not find a single match in this if statement, then how? Then after all of this, I should actually catch this case under another if statement. How? Here is the code. And see, what did I miss? So that's a great follow-up question for controlling program flow. You can use the for else structure in Python, or a simple boolean flag to check if the loop completed without finding any matches, etc. Okay, since you need to reveal only one match and then stop, the for else structure is the most Pythonic and clean way to handle this. Using for else. The else block attached to a for loop executes only if the loop finishes normally. It reads over every item without being terminated by a break statement. In a specific case where you are trying to reveal one match and then stop, you should use the break to signal success. Put the no match found logic in the else block. Here's you can do it. So for index char enumerate, if the char equivalent to the guess, then we're gonna add it. Print found match at index at this index. Stop the loop immediately after the first successful reveal. Okay. Oh, interesting. That's very interesting. Then we are going to break this for loop. And then we're going to use the else. Case use only if the break was not hit. Okay, interesting. So okay, that's very smart actually. So we could actually delete this for the moment. Okay, we could add here an else statement. Dependence in here. Then we could say lives -1, and then we could print lives. Okay, lives, yes, beautiful. So okay. Okay, that's interesting. Maybe we could delete this for the moment, copy and delete it, and see how we could do this, because it's a little bit. So we could break if you found an index, and then we could make an else statement, not in this indentation. Okay. In here, we could do the else statement in here, and this should function, right? Because this is very smart. Okay, yeah, this is very smart actually. Let's play. What is it? Okay, so let's just troubleshoot this, see if it works. Let's use, for example, P. Then we have 5 lives, and okay, it works finally. perfectly. Okay, let me just thank AI. Tell him thank you, master. You are my soul master. You are very welcome. I'm glad you could have solved that logic puzzle. Happy coding. Let me know if you have any other questions as you continue building your program. Okay, beautiful. So yes. So actually, if this was true, and we found that, then we're going to break this for loop, and then we are not going to execute this else statement, okay? But okay, let me repeat. If we found the right index, if the guess was correct, then we are going to break this for loop, then we're going to execute this as a whole. If we didn't find, then we're going to use this else right over here, which is fine. Okay, so I guess the game is done. So what we need to do right now is just add a GUI for it. So yeah, this is the easy part of the development. Okay. So here I could remove this. Okay. Okay, here it shows me how much lives are there. Interesting. So that's very interesting. So let us go to the demo. Okay, so here's the demo, and we're going to copy all of this, I guess. So yeah, so do we have something else to do? If guess is not a letter in the chosen word, then reduce lives by 1. If lives goes down to 0, then the game, okay. So this one is finished, all of it. So we have to do number 3. Print the ASCII art from the list stages. Okay, so here, over here, stages that corresponds to the current number of lives the user has remaining. Okay, interesting. So if the user have, so how much stages we have in here? We have 1, 2, 3, 4, 5, 6. Oh much, that's too much actually. We have 1 stage, 2 stages, 3. 1, 2, 3. So this is one is for the game over, I guess. So yeah, so we have 7 stages. Okay, interesting. That's very interesting. So we are going to remove all the prints in here. So this is a list, so we could use the indexes to print each one depending on the lives number. So here is the code, the algorithm that we are going to use. And here we are having our display. So let's type here, for example, A. Okay, interesting. So we are going to print display in here. Okay, then we are going to print before the display. We're going to print this, how much lives left. Okay, let me just copy it. Beautiful. Let me access PyCharm. Why can't I access PyCharm? That's weird. Okay, let's see. Why can't I access PyCharm? My god, this is a glitch or what? Like, this is the weirdest glitch ever. Right now, PyCharm can't go on top of Brave. It's alright, no problem. Okay, so we have display, etc., and then we are going to print. Let me see the demo. So we are going to print this, lives left. Okay, print here this thing. Okay, lives left. Here we could actually change 6 out of 6. Here we could change this to this, and then it's gonna be lives. Then we could use an f string in here so that we could call this variable inside of the string. Okay, let's test this later real quick. Okay, so we have here a b. Okay, that functions alright. An in functions alright. Maybe a p. Okay, beautiful. So it functions as it's supposed to be. That is sweet. Okay. Now we just need to improve our stages. So if we saw Brave, we are having if we made a bad letter, we are going to say you guessed B. That is not the word, you lose a life. Okay, that's very interesting. I'm just gonna add that. So we're gonna print here print. Okay, I'm gonna add, you guessed, I'm gonna add this. I'm gonna go and add here the guess variable. Correct. I'm gonna use an f string in here. Beautiful, so that's done. And here we have the stages. And with the stages, we are going to use, let me access PyCharm. With the stages, we are going to use an if statement, maybe. Yeah, we are going to use if statements for that. Okay, so we're going to do this if statement in here. So f lives is equivalent to 6, a column, then we are going to print this GUI. Are going to take the stages and take the very first index stages. Oh, interesting. Yes, 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 we are going to use lives. That is very interesting. Oh, with this syntax, we are not going to use, oh my god, I'm not going to use the if statement. That is just so much smart from the AI that is integrated in PyCharm. Crazy. Okay, so this should function as the demo. Let's see. A. Okay. Guess a letter. We have guessed A. This is the amount of lives we have, and this is the first stage. Let's see. Okay, interesting. So the stage comes after this one, so let's just do it. Okay, let's go in here. Take this one, copy it, delete it, and then no, just keep this one as it is. I'm going to copy this one. Yeah, I'm gonna copy this one actually. And I'm going to paste it in here. I'll copy this one and paste it in here. Maybe that's how it's supposed to be. Okay, let's see. So yes, we have the display, we have the stage, and then we have the amount of lives. Let's check that. Display, stage, and amount of lives, correct. And if we have fields, we just type that as the first thing. Guess a letter P, etc. Okay, beautiful. So this actually functions just alright. Let's see. So we have a C for camel. Okay, let me just not print the chosen word, because that is cheating right now, because it seems that everything is functioning just fine. Let's guess a letter. What about C? Okay, so for C it is correct, and we have 6 lives. And what about L? What about M? What about A? What about L? And then we win. That's simple. Okay, interesting. Interesting. Okay, here we could actually output the display as a whole if we want. Game over, print you win. Display, blah blah, you win. And then we could print here as well. I could print display. So let's do it. Yes, display, correct. Okay, interesting. If guess is not a letter and chosen earlier 2 slides by 1, print the ASCII art from the stages that corresponds to the current number of lives the user has remaining. Okay, so the game is done, and I guess the life is done. I'm just gonna do an experiment with it as well. But before that, I'm just gonna go and change this word list. I'm gonna ask AI to give me, I'm gonna ask Gemini 3 Pro, please give me a better word list for the Hangman game. Then it's gonna give me a better list. I'm gonna wait for it, and then we're gonna play the game through our PyCharm console. Okay, interesting. So we have all of these words. Then we have an output error. Okay, interesting. I don't know why. Why there is an error. That's weird. Okay, that's very weird. I know it's errors, but I guess this is enough words for the moment. So we are going to add this to our list. Paste. Okay, okay, here we have an error. Okay, then we could close this list. Okay, beautiful. So this should function as butter without any problem. So let me guess A. Okay, A is correct. What about B? Oh, B is correct. What about L? Oh, so L is wrong. What about N? N is wrong. What about W? W is wrong. What about U? U is wrong. Oh, U is correct. Is it balloon? Baloo. I don't know. Okay, what about G? Oh, it's not functioning. How about D? Okay, it's all wrong. You guess D, that's not the words. You lose a life. This is the last try. What about Z? What happened? What about C? What do I recover lives? I don't know. I'm recovering lives. What's happening? There's an error. What did just happen? Okay, interesting. That's very interesting, actually. Okay. This is weird. Let's choose B. It's wrong. O. It's wrong. E. Okay, E is there, so it's correct. U. U is there, so it's correct. Y. It's wrong. T. Wrong. What about V? That is wrong as well. What about Q? That is wrong. So here we have 0 lives, so we should die actually in this point. But why we don't die? Interesting. Why? Why lives are not equivalent to 0? That's the problem. And the while loop. So like this, we should actually have a game over. Let's see. A. A is correct. E. E is false. A. A is false. C. C is correct. What about an M? M is false. What about U? U is correct. What about S? S is not there. D is not there. What about G? It's not there. So we have 0. And we should die. What? Why? Why we are not dying? That's interesting. That's very interesting. So we should break this while loop, isn't it? Let me troubleshoot this. Oh, that's weird. Why the while loop is not breaking? After lives equivalent to 0. Let's see, why is that? The logic flow. The problem is, or in your while loop condition, the logic flow you wrote. Yes, just look what happened when you lose lives become 0, so lives is false. You haven't guessed the words, so there are still underscores. So okay, in Python, true or false results in true. Okay, because the result is true, the loop keeps running even though you have 0 lives. The solution: we want the game to continually... okay, so we need to do an N. Interesting. That's stupid from me. Sorry. Okay, so let's just revise this. So this one is true, and this one is true at the beginning of the game, so it's gonna give us true. But this one is false, and this one is still true. And when we have an or, then the loop continues, which is wrong. That's the problem. Okay, that's great. Okay, let's see. P, it's false. W, false. E, false. G, false. V, false. C, all of them are false. What? So it has finished right away. Okay, interesting. You guess the C, you lose your life, etc., etc. We're gonna make another if statement in here. If this still in display after the while loop has been broken, so in this case, then print game over. Okay, and then print display. Let's see how that's gonna go. We're not gonna print display, actually we're gonna print the chosen words. Yes, the chosen words. Yeah, correct. So let's see. P, it's long. O is wrong. O is right. E, okay, what happened? Okay, seems that we had a problem. Y, R, H. So it's a game over, buffoon, etc. So the game actually is complete, and we could go to the next project. So yeah, we are going to go to the next project because this is done. Improving the user experience. I don't care about that. So here we're gonna go and see the final video.
Hey, well done for completing day 7. Now, you've come a long way since the very beginning, and you've been here long enough to know what the drill is. You just gotta keep showing up, keep doing the days. But don't worry if it takes you longer than 1 day to complete one of the days in the course, because you might have kids, you might have a really demanding pet, you might have a really difficult job. And in fact, I was learning iOS development while I was working as a doctor, and I had to do that after I came back from a night shift.
Actually, this is very tough. She works as a doctor and does Python after she did night shift. This seems like Superman powers, Superwoman. That's crazy.
And it just was so hard when my brain felt like mush and I was so tired. But the important thing is that you're putting in that daily repetition, that you're doing it continuously, and you're not spending a long break in between each lesson. Because this way,
Yeah, I do really like breaks.
the content can feel fresh in your mind when you come to it. So don't worry if each day takes you 2 or 3 days to do, just keep going. It's a whole linear calendar. It's a whole linear process. As long as you follow the order, you'll get there eventually. So keep going, take a break, and I'll see you tomorrow.
I'm not taking a break. I'm doing a crazy live stream, and we're gonna make a lot of days in here. So my goal is to, my god, that's crazy amount of days. But we're gonna do a lot of things, okay? I'm not giving up this.
Hey guys, welcome to day 8 of 100 Days of Code. And today we're going to be looking at functions that allow you to give them inputs. And once we've learned all of that
Okay, that's interesting. Let's learn about it.
and we've grasped it, then we're going to be building a cipher program. And the cipher program is called Caesar Cipher. So Caesar cipher is a really quite ancient type of encryption. So the story goes that when Caesar wanted to send highly sensitive military messages, he would encode his message so that each letter would be shifted by a predetermined.
Okay, this is a very basic algorithm. Pretty easy to do with Python, so an easy project. Easy.
Amount. So let's say that we wanted to encode the letter A and we shift it by 3. Well, then A becomes D, B becomes E, and so on and so forth. And this is what the final version will look like. Let's go ahead and encode something. So I'm going to type encode to start encrypting a.
So we do use a lot of encoding terminal commands, and there is a lot of encoding that we use throughout the web as well. So give me a command to encode a word in the Linux terminal. Okay, that was a little mistake spelling, but it's fine. Just we're gonna see a lot of commands that do it. Okay, so here we have this base 64 encoding. This one is used a lot in web browsers, in API, etc. So we're gonna see it in the Hack the Box machines. We're gonna need to decode this a lot of times, and there is a website for this as well, which is a Chef in GitHub, as I remember. Chef.io. Yeah, maybe this one. Yeah, I don't really remember which website. Yes, this one. So here we could take an input and encrypt it to base 64, for example. Let's say I want to encrypt hello world. This website is for free and it's very helpful. Look at the output. And we could do the same with the bash console. So let's make it over here. Clear the screen. Then I could type echo hello world underscore world. I'm gonna pipe that to base 64. Yes, and we are having almost the same. We have AG, VS, BG9, BG9, FD29, FD29, YBG, and Q. But rather than this equal signal, we have a big Q in here. I guess if we add this parameter, it would fix, I don't know. Let's see. Okay. This one, how to decode it. So this one is for decode, this parameter, interesting. Okay, so let's ask AI. Why did CyberChef.io and GitHub encode hello world like this? Hold on a second, let me just copy it. Copy and equal sign and the bash terminal encoded it like this. Okay, let's see the terminal, and that's the encoding of the bash command line. You see why there is this K and not the equal signal. That's pretty interesting actually. So the model is thinking, which is a little bit of an overkill, but so fine, it's fine. You see the difference occurs because the Linux terminal adds an invisible neoline character, okay, to the end of your word, while CyberChef does not. the explanation, CyberChef encode exactly what you typed. Terminal encoded what you typed plus a hidden enter key press at the end. Ah, interesting. This is very interesting. The extra character changes the binary data, which changes the resulting code. How to fix it in terminal? To get the exact same result as CyberChef, you must tell the terminal not to add that new line. You do so in code. For example, we have this bash language. It is actually very recommended to add a new line after your command line. Like in Python, if we saw in here, if we didn't have this new line, we're gonna have this ball right of here. Okay, interesting. So if we didn't have this new line, then we're gonna have an error. It says whatever to whatever, and then you have to add a new line. This is what I have remembered from this course, so it is a pretty basic thing, and programming languages. So you see, here we ask with this parameter, which is -n, to not you add a hidden new line, okay? And then we have the same result, which is very interesting. Okay, fine. New information, isn't it? Let me just delete these 3 box worlds and complete our cipher journey.
A message. And then I'm going to type my message with no spaces in between. And then I'm going to give it a shift number. So this is going to be a number that the recipient and I are going to agree on so that we know how to decode the message. Let's put that at 9. And then it's going to give us the encoded result, which is something like this. And this will be the message that I'm going to transmit to my friend, either through a letter or through an email. And it means that whenever somebody comes across this message, they won't really know what's going on unless they knew the shift number. So let's say that I am my friend. I've just received this message, and I'm going to go ahead and type yes to go again, and in this case I'm going to decode instead of encoding. And then I'm going to type out the message from previous and hit enter.
Okay, that's interesting. So here we have the sequence, encode or decode for decryption. Then we type our message, and then we type the shift number. Then here's the encoded results. Type yes if you want to go again, otherwise type no. And then we decode, and then we type the same shift number.
And of course the shift number is 9, and now I have the decoded result, which I can read and understand.
That's very interesting. Let's see if we have the demo in here. Let's see. Yes, we do. Let's click run. So we want to encode hello world. I'm gonna choose a shift of 288. So no, I have made a mistake. Let's repeat it. So type encode. The message is gonna be hello world. The shift is gonna be 289 actually, 289. Then this is the encoded result right over here. Okay, let me just copy it, all of this. Beautiful. And then type yes if you want to do another sequence. And then type decode. Then type the message. Okay. This is not an optimal terminal, I guess. Then we're gonna type the shift in C. Here's the decoded result. Okay, so this didn't work actually. It seems that there is some kind of problem. Not type no. Says goodbye. Let me run it again. Type in here decode the message, then the shift. Nah, it doesn't work. And this is a broken program, I guess. So let me encode hello. The shift is gonna be 200. Okay, this is way better. I'm gonna copy that. I'm going to decode this, type the message, then the shift number is actually 200, and then the decode. This doesn't work. This doesn't work actually. Okay, this encodes again. Type the message is hello. The shift I'm gonna use 5. Okay, so this is very simple. I wanna type yes, type decode, the message is hello, the shift is sorry, that's wrong, all of this is wrong. Let's just repeat it. The shift is 5, remember. Decode, the message is this. Okay, the shift is 5. See, yes, so it works for smaller shift numbers, but when you go with a big shift number, then it doesn't work, which is not optimal. At least you could set a limit of the shift numbers, at least. Okay.
By the end of today, you would have learned about functions with inputs. You'll know what the difference is between arguments and parameters. Once you're ready, once you're loaded up on coffee, then head over to the next lesson and let's get started.
Okay, fine. Okay, so let's continue.
To get started, we're going to learn more about functions. And previously we learned that functions are a really handy way of taking a complex set of instructions and packaging them together inside a block of code
Yes, that's true.
that has a name given to it. And when we need all of the lines of code that's packaged inside this function, all we have to do at any point later on in our code is just to call the function by typing its name and then a set of parentheses. And when this line of code is run, it's going to search for where this function is defined, which is up here, and then it's going to execute all the lines of code that are contained within it. Now, it's been a little while since we've seen functions, so to begin, I want you to create a new function called greet. And I want you to give it 3 lines of print statements telling it to do 3 things. And finally, once you're done, go ahead and call the function so that it gets executed in the console. So pause the video and give that a go. Alright, so to create...
Okay, so I'm gonna make this happen. We're gonna go for the next day, which is day 8, functions with inputs. This should be very basic and easy to do. Okay, pause and review. Create a function called greet. So let's define a function called greet. Okay, column. Okay, sorry for that. Column, and then it's gonna print 3 times statements inside the function. Or 3 print statements inside the function. Okay. So we're gonna copy this, and paste it again, and then we're gonna call this function greet, yes. Then we're gonna run the script, and there we go, easy. By adding a variable name inside the parentheses, when we define a new function, it allows that function to take inputs when called. That means we can modify how the function behaves each time by passing in different inputs. Okay, interesting. So like this, we could make adaptive functions that, you know, adapt to certain cases, which is very nice. So we could create this function which has inputs in it. So that's very nice. Let's try it. So I'm going to comment out this, and then I'm going to define another function called, for example, player input. And then I'm going to add this inputs parameter over here. Beautiful. Then I'm going to print like this an f string. I'm gonna call it hey, tell us the name of the player. Okay, that's beautiful. Okay, so I'm going to execute this, and we could use here when we call the function. So we need to call the function first, and then we could enter our inputs. So it's going to be strings, and then we could say the name of that player is Messi, for example. Who knows? Then it executes like this. She's very adaptive, you know what I mean? Beautiful.
In a function, we of course need the def keyword, and we know it's a keyword because as soon as we type it, it changes the color. And after the keyword, we get to give our function a name. So in my case, it's called greet. Now, after the greet, we add a set of parentheses after the name of the function. Finally, we add a colon and we enter into the block of code because we're indented over. Now, the first thing I'm going to do is to create a print statement that just says hello. And then I'm going to say, well, how do you do? Now, nobody in England actually says this, but I always see it in the Learn English books, which is quite funny. I think people will give you very strange looks if you go.
How do you do? It's pretty weird. Isn't the weather nice? Okay. So all of this is a waste of time. Just go to the meta. So I see this in detail over here. Okay.
These parentheses. Now, what we can do is we can actually add the name of a variable inside those parentheses to start giving our functions some inputs. So let's say that there's a variable called something that's going to be passed to my function. And this something can then be used inside this block of code, this function, and I could do something with it. Now, in order to actually pass this value when I call my function, I have to add the data inside the parentheses. So let's say I decide to pass 1, 2, 3 over. Well, in this case, when this line of code gets triggered, the computer is going to search for where this function is declared, which is up here, and then it's going to pass over this piece of data, 123,
Okay. Yes, that's true.
over to this variable called something. So now, effectively, inside this function called myFunction, we now have a variable called something that's equal to 123. And that can then be used inside the block of code to do something with that piece of data.
That's very interesting.
Now, it's a bit like plugging a USB stick into a computer. If we took a different piece of input, we would end up with a different file being shown by the computer. So this means the computer can do something different depending on the input that
Depending on the input, that's okay. So it is more adaptive, this manner, to the case, to the situation that we are in.
we give it. And if we change that input, then it will receive a different piece of data. So in addition to a simple function, we can also create a function that allows for input. And to do that, you saw earlier on, the syntax is again the same as before. We use a def to create the function, and then let's just give it a slightly different name to differentiate it with the previous function. Greet with name. And then inside the parentheses, instead of leaving it blank, we get to create the name of the variable that's going to be passed over.
Okay, that's pretty interesting.
So let's just call it name, because that describes.
Okay, we have done that. Say yes. So rather than calling this input, we could call it name. Okay, and then we could actually change or rename the function input, which is this variable name, and it's going to do the same job. Let's see.
When we actually call this function, it's also going to be a little bit different from previously on line 6. So now, firstly, the name of the function has changed, but notice how it's expecting some sort of input inside the parentheses, and it tells me that it wants to receive a name. It's when we call the function that we actually pass over the piece of data that's going to be stored inside this variable. Let's give it my own name, Angela. And now when I hit run, I want you to predict what's going to happen, what's actually going to be printed.
So it's going to print it. Hello, Angela. How do you do, Angela?
So let's.
This is very basic, so we could actually skip this. We could go to the next course.
In the last lesson, we saw a very simple form of a function that allows for an input. Now in this lesson, I want to take it even further, and I want to create a function that allows for multiple inputs. So let's comment out the previous line of code, and let's create a new comment, functions with more than one input, and I'm going to create a new function called greet_with. And in this case, it's
okay, so we define greet with name, etc., etc. So here we're gonna define functions with more than one input, and we could actually play with that before we see the course, which is it's not that much of a difficult thing. So you could define so here is gonna be player name. Here we could define another function and call it player choice. Okay, and for the player choice we're gonna have the situation, and we're gonna have answer. Okay. If situation equivalent to answer, this one is a little bit too far, so we're just gonna use print. Very basic. So you choose plus situation. No, it's not gonna be like this. Sorry, but no. I'm gonna print hey, tell us the choice of the situation. I'm gonna print again. We're going to print the I'm going to print a string, an F string. Hey, tell us the choice of A plus tell us the hey, please tell us your answer. Your answer. Okay. And then we're going to call this player choice. So the situation, who are you? So the situation is gonna be pressure, who knows? And the answer is gonna be calm. Oh my god, get back. Situation is gonna be, the answer is gonna be calm. So seems interesting, right? Okay, what happens? What is happening? Oh yeah, in here. I could comment out this. This is irrelevant for the moment. Okay, so here tell us the choice of pressure. That doesn't make any sense. Hey, please tell us your situation. Your situation. Situation. You are in. Tell us your situation you are in. And then I might say. I am under pressure. Okay, please tell us your answer. I'm gonna say I will calm myself. Something like that. We are in. I am under pressure. Okay. Okay, so this is just fine. Interesting.
It's going to take 2 parameters. It's going to be name and location. If you remember, this is how we added a parameter previously. Now, as a challenge, I want you to quickly think about how you might add 2 parameters. One's called name and one's called location into this function declaration. Pause the video, have a brief think, and then we'll go through it together. All right, so we know that if we wanted to add one parameter, name, then this is how we would do it. We would just add it inside the parentheses. Now, if we want to have more than one parameter, all we have to do is just add a comma and then add the second parameter, which we said was going to be called location. So now this particular function is going to take 2 inputs, the name and the location. And then inside this function, we're going to use the name to print something like hello, name, and then we're going to print and ask them what is it like in their particular location.
Okay, hello, then your name. What is like in your location? She's way better than me when it comes to this. But it's okay. But the challenge is like very basic. It's the same one as what I did, so yeah. The name is Jack Bauer. Location is nowhere. Pretty creepy, innit? Okay. So just greet with. Interesting. So here we have 3 parameters or arguments.
Typing out the code, you get the hints here as to which piece of data you need to enter, but also you can refer to the function and look at the order of the parameters. Even if we had more inputs, let's say in this case we had A, B, and C, and we put the arguments 1, 2, and 3, then it means that our variables that gets created will be A equals 1, B equals 2, and C equals 3. Now, if we switch around the order of the arguments in the function call, now what will happen is A is going to be equal to the first argument. So A is now equal to 3, B is equal to the second argument, and C is equal to the third argument.
Okay, that's interesting.
So it might be doing slightly unpredictable things in here. So whenever you're creating code and you're using these positional arguments, and you're just inserting the data one by one like this, and it does something completely unexpected, then be sure to check your positioning and to make sure that it matches with the position of the parameters. Now, what if you wanted to be more clear when you actually call the function so you don't ever encounter this problem? Well, you could use something called keyword arguments instead. So now, instead of just adding the arguments into the function call,
You could actually specify, okay, that's really interesting. That's pretty basic as well. So rather than choosing this, I could choose answer and say maybe column. Okay, column. Okay, beautiful. Then I could use here situation, and I'm gonna call it I'm under a rainy weather. So then call, my answer is gonna be I will get to home by myself. So let's see how this functions. Okay, we have an error. Okay, in here I have a string that is weird. Okay, here tells us your situation you are in. I am under a rainy weather. So that works just fine. So the situation is in here. It is not as defined in here. So that's a different position because we just made our what's called again? Keyword argument. So yeah.
like this, we can actually add each of the parameter names and an equal sign to say that the first parameter A should be equal to 1, B should be equal to 2, and C equals to 3. And now when we actually change the order around, it doesn't matter how we order it, it's still going to abide by these bindings. So C will still be 3 and A will still be 1. As a challenge, I want you to take this previous function, greet with name and location, and I want you to call this function down here. But this time, instead of using positional arguments, I want you to use keyword arguments. So pause the video.
Okay, I just did that. So there is no need to do that, so skip it. Okay, so we have done this and this and this. Let's continue to here.
All right, it's finally time to tackle our
Finally.
final project, the Caesar cipher. As I've mentioned before, Caesar cipher is this way of encoding text that was seen as early as during the times of Julius Caesar. So when he had these top secret military messages, what he would do is he would shift each letter of the alphabet by a certain predetermined amount. I want to show you quickly how this works. So we've got the alphabet here, and let's say we wanted to encode the letter E. So now we can line up the alphabet with a new set of alphabet, and at the moment,
And we could shift all of these depending on the shift number.
the shift is 0 because the top alphabet and the bottom alphabet are lined up with a 0 difference. Now, let's say that we had a shift of 1. Well, then the alphabet moves to the left and A becomes B, B becomes C, etc. And we can keep going until we get to the amount of shift that we wanted. So let's say we're going to encode all of our text with a shift of 3. Well, then E becomes H, F becomes I, G becomes J, etc. And so on and so forth. And they've actually discovered these artifacts from ages ago where people have created these sort of dials. And by simply rotating the dial to a certain amount of shift, then you can line up the letters with each other. So A becomes N and Z becomes O, and so on and so forth. And this is a way that people actually encoded top secret messages. By the
This is a very interesting tool.
end of this day, you will have also built a digital form of the Caesar cipher. And all you have to do is to type encode to start encoding a message. Let's say something like, hello world. And once we hit enter, we get to type the shift number, which I'm just going to choose a random one. And it gives us the encoded result.
Okay, that's interesting. And then you decode it with the same shift number.
So if there's people monitoring your phone, or you're trying to throw a message to your friend in a paper ball, then this is an easy way to ensure that if your message was intercepted, then it won't be understood by the other person.
All right, so once you're ready, let's get started building out the Caesar cipher. Now, you'll notice that I've split it into 3 parts. So 3, 4, 5 are all the Caesar cipher. And that's because there's quite a few things to do. And I thought it might be a good idea to break it down into separate lessons so that we can go through them individually. And hopefully it'll make this very large problem a little bit easier. And we practice that key engineering skill, which is breaking down a large problem into smaller problems and then taking a small problem, breaking it down into even smaller problems. That is the only way that we can get through really, really hard problems.
Yeah, that's true.
All right, so you'll notice that in Caesar Cipher 1, I've split the tasks into 4 to-dos. You'll notice the order is a little bit weird because it goes 4, then 3, but they're roughly at the places where I expect you to write the relevant code. So it's not a mistake, it's actually very much on purpose. Now, what I want you to do is to go through each of the to-dos and read through their descriptions on the right-hand pane and try to solve them. If you get stuck, there are some hints in there that will hopefully help you. But essentially, the really important thing is you actually read through the to-dos, because some of the things we might not have seen before. For example, in order to complete the task, you will need to use a built-in function called index. And index is really
Okay, so I guess we just have to tackle this rather than hearing her saying random stuff that are not that important. So here is not that important. So yeah, so we're gonna start from here. These are the alphabets that we are going to use. And we have duplicate code fragment 5. Okay, and we're just gonna go and ignore that. Okay, so to do first, create a function called encrypt that takes original text and shift amount as input, as 2 inputs. That takes these two. Okay, interesting. Okay, so we're gonna define a function called encrypt, and it takes original text as input, and it takes as well shift amounts as input. Okay, beautiful. So, and for to do 2, inside the encrypt function, shift each letter to the original text. Okay, so here into do 2, inside the encrypt function, which is this one, shift each letter of the original text, which is this one, alphabet, I don't know. So this one, this is the original text, forward in the alphabets with the shift amount and print the encrypted text. Okay, this is very hard actually. So first thing first, we are going to shift each letter of the original text. So we're gonna have, for example, we're going to comment out this line first. Then we are going to make our own text for the moments, and we're gonna make it as equal. A string is gonna be hello. Okay. So this is the original text that we are going to work with. And we are going to shift each letter. So we are going to take text lists. So we are going to use lists for this. Text lists equals list function. And we're gonna make it for text, right? Yeah, that's right. Okay. So what's the point of these if I'm not using them? So yeah. So this one's gonna take the text. Okay. It's gonna be the original text in this case. Original text. Yes. And yeah. We're going to define this variable. And okay, so we're gonna need to shift this list. Maybe we're gonna use the for loop. So for character and the text list, correct? Have the character and alphabet. Okay, that's interesting. Let's see. Oh, he removes this. What are you doing, AI? Stop. Stop giving me these suggestions. They are stupid. Okay. So for each character in text list, which is HELLO. Okay, so we're gonna go through H. We're gonna find this in here. So for character and this text list, how should we do this? Interesting. So I guess we have to map out this alphabet list as well. We need to take its indexes. Okay. Okay, so I'm gonna delete this and see what we should do. Okay, so we are going to go through H. So car, remember right now in this case, our first character is H. Okay, so this is very important. Please stop giving me suggestions. Okay, beautiful. So here for character and text, which is H, and we are going to map out H in alphabet. So we're gonna take alphabet. Oh my god, this AI is annoying me. Alphabet. And we are taking it as char. So we are taking this index of char. And then we are maybe we need another empty list for this purpose. It's gonna be the I'm gonna call it list. It's gonna be an empty list for the moment. Oh my god, what does this do? Text if char and alphabet listed up in char. If character and alphabet, then append it. Oh my god, this AI is annoying me like so much. Okay, let's see what we could do in this case. We are going to take this alphabet and we're gonna take its index. Okay. Let's move on this through Johnny. It's gonna help me a lot. Thorny, actually, Thorny. Ubuntu. I'm gonna need this one to actually understand what I'm doing. Okay, town is dedicated to Ukraine fighting the Russian invasion. Please support Ukraine. Yeah. We're gonna choose Linux. Install private Python, etc. So bash, blah blah. Flatpak install. Okay. I do have Flatpak and I do have Snap. And I do have Debian. All of this. Let's use the Debian one, the most secure one. And press enter. And by that, we're gonna have Thonny. We're gonna want to upload our code to Thonny so that we could visualize what's happening to our code. So yeah, it's very important. Okay, so let's get to Thonny. There he is, standard, let's go. Beautiful, so we're gonna copy our code. So Thonny is very important, especially if you need to visualize how the code actually executes. Okay, let's execute, let's make this bigger. Okay, so yes, we have an error in here. Let me make anything in here so that I could visualize. F maybe. So run right now, there is not an error. Okay, here debugging. Okay. Debugging the program must be saved first. Dash save. I'm gonna put it in documents. I'm gonna create a new one. Oh my god. Documents. Create a new file called Thonny debugging. Okay. Then we're gonna call this Cypher. Python files. Yes. Okay. This debug. Okay, beautiful. So we could just step out this, step out. Interesting. Okay, F. Oh my god, and you have to text out all of this. Let's make comments out all of this. Comments out. Okay. Then debug again. Okay, what's happening? Stop. What's happening here? Stop. Debug. Okay, beautiful. So it's working. Step out. Step over. Okay, so step over is working. Okay, so let's step into etc. So here. Okay, beautiful. Here we have a warning, etc. What? List. Okay, let's delete this because I'm not using it. Okay. Let's debug again. Step out. Okay, beautiful. And here we have hello. Then he doesn't do anything. What? What? Why is this debugging not working? Help. Maybe ignore if you're happy with your program. And use argument shift amount. Okay. Because I don't call the function, that's why. Okay, let's call it. Let's remove this as well. So it's a little bit to debug, a little bit difficult. We are going to call this encrypt function, encrypt. And then I'm gonna input text as an argument. Now, right now it should work. Okay. Okay, step out, go, beautiful. And then right now we are executing this function. Okay, interesting. Thank you. Okay. It's complete. Why is this not happening? I don't get it. What's happening here? What is this? Oh my god. Okay, here. Okay, so we see this happening over here. Okay, we could resume it, we could step out, step into. Okay, and we have an error. So this error I want to play with. See what's happening in here. Text, etc. It's hello. Okay. Okay, beautiful. So here text lists. We are transforming this into a list. Beautiful. So for chart in text list, which is that list, so we're going to take H and we're going to take its index, right? List indices must be integers or slices. And we have a problem, okay. No problem. I'm going to take a break. I'm going to ask AI how to take the index of the H letter in alphabet. So if I know the index, then I could actually forward more. Here we have Thorny. What are you doing here, Thorny? Get off. Get out of here, Thorny. Okay, we could type stop and then that should be solved. Okay, beautiful. I'm gonna take a break and tackle this challenge because it is not easy. It is a challenge. So, yeah. Okay, let's continue. Okay. It's perfect. So we have made it through the first to-do list, and I guess we will do the 4 to-do lists, all of them. I guess I'm gonna go and end the live stream because that seems to be enough. Like 4 projects or 3, I don't know how much. And this may be the 3rd or the 4th project, so it's kind of enough, right? I think so. Let's do it. So first of all, I'm just gonna use a little bit of AI. I'm not gonna cheat a lot, like just the minimal. So I'm gonna go and check this to-do list. So create a function called encrypt that takes original text and shift amount as to input. That's cool. The first to-do list is done. The second is the one that is difficult. So inside the encrypt function, shift each letter of the original text. So original text forward in the alphabet with the shift amount. Okay, and print the encrypted text. And I'll have to encrypt the text and print it. Okay. So this is very easy. I have to first of all make a little of notes on how to divide this. So first step actually is to get the index of the letters in text. Okay, variable. This is the first thing that I should do. And when I know their indexes in alphabets, so letters, the index of the letters of text in of text variable in alphabets list. Okay, so this is well formulated. Second thing is when I know their index, I'm gonna go and add the shift number or amount to each character index and get them in a variable called encrypted. So this is the mechanism that I'm gonna follow. Encrypted text. Okay, so I'm gonna manipulate these lists. So after this, I'm going to print. This is the easiest one. Print the encrypted text. And for the decode, you're just gonna reverse this, mechanism. So we'll just do it. So I'm gonna define encrypt. It's gonna take original text and shift amount. So I'm gonna take this list. Okay, so original text list. So original text list. Okay, I'm gonna use it here as well. Original text list. So the first thing is to actually get the index of the letter of the variable in the alphabet list. Okay, so I don't know, but using AI is not that much of a cheat if it was just a little hint. Okay, just a little hint is enough. Okay, I could delete the first to do because it's unnecessary. Okay, I'm gonna make a new playground. I'm gonna ask, could you please give me a little hints of Python syntax so that I could spot the index of the characters of the text in the alphabet list. Okay, I'm gonna paste this for reference. And please do not spoil the learning from me. Okay, beautiful, and paste and enter. Okay, so it seems to be there going. So he just getting my thing. So you are very close. The issue is in the syntax alphabet char. Okay, when you use square brackets like lists, Python expect x to be the number and integer to find the item at that position. You are currently feeding it a little like h, which confuses the computer. You want the opposite. You have the letter and you want Python to tell you its number, position, which is its index. Here's the syntax hint using a different example. So we have here color, red, blue, and green. To find the position of blue, you could use this function. And when it prints, we're gonna have number 1, okay? You replace your line alphabet char with the method, okay, beautiful. That's why I'm using AI, because it is your teacher, okay? So here, I lack the syntax knowledge, but with AI, you just don't need to, you don't need to Google it, the syntax or how to do it. With syntax, you could actually just use AI. It's gonna be like a teacher. He's not gonna spoil your learning, okay? So for my so I'm gonna take an empty list called positions. Okay, beautiful. And I'm gonna go for this for loop, and I'm gonna add to this positions list. So I'm gonna call positions, positions. Oh my god, what's wrong with this? Positions equivalents. This AI recommendations are annoying. So I'm gonna take the alphabet dot index dot char, and I'm gonna store it in positions, right? Yes, I guess I'm gonna take this one first and define it with the function. Yes. Okay, beautiful. Beautiful, isn't it? Okay, let's tell him. What is this? What is this? 4 letter in alphabet, position up in alphabet. Who made this? Who made that? Who made that? Who gave it to the... No, I didn't do that. Oh, that's weird. Key, prints, encrypted text, def, okay. That was weird, but it's done. Okay, let's say to the AI, is this correct? Okay, let's see. I hope it works. So you nailed the syntax for finding the number alpha meh is exactly right. However, you have a small logical issue with how you are storing that result. In your loop, positions equal sign replaces the value of positions every time the loop runs. You start with positions as a list. After the first letter, position becomes the number 7. It's not a list anymore. After the second letter, same becomes the number 4. Okay, if you want to add an item to the end of the list without deleting what was before, you can use append method. Okay, beautiful. So I could use this positions.append rather than using the equal sign. So I could add the append function. And I could just do this. And I have added the positions. Okay, so I could just print positions. Okay, and I'm going to call this function so I could troubleshoot it. So I'm going to call this function. Okay, encrypt, and I'm going to input the original text, which is text, and that's it. Because here I'm not using shift amount, I'm just gonna delete it, and like this, and it should work. Let's see. Didn't I actually comment out this? I have to comment this out before I could start, because I'm not using those for the moment, because this is a lot of work actually. Okay, so we're adding 7, 7, 4, 7, 4, 11, 7, 4, 11, 11, which is true LL, 7, 4, 11, 11, and 14. So after I have all of these values, okay, so after I have these values, I have to add 1 to each of these indexes. So I have these values. Okay, that didn't copy. Okay, copy, beautiful. And I want to add the shift amount, which is an integer, and I want to add the shift amount to each index in the positions list. Let's do this. Let's see how is this gonna function. So this is the mechanism I'm willing to follow, which is a very, very smart mechanism. So you're actually using lists and manipulating them to do your work. So yeah, you're making great progress. You have the logic down perfectly. You have a number, the index, and you want to add a number, the shift, to it before storing it. Okay, you can actually do the math right inside the parentheses. Python will calculate the math first and then append the result to your list. Hence, modify your append line to add the shift amount to the index number directly. Okay, calculate index plus shift first. Plus. Okay, so he's been a teacher. Help. Okay, calculate index plus shift first, then append the results. Okay. Interesting. So what AI says to us that, okay, so here at this line, I'm going to need to add to this index a +1. I can't believe this. I can't believe this. So we're going to see here 8, 5, 12, 12, and 15. So rather than +1, we're just going to add the shift amount. And we're going to add the input in here as well. Okay, shift. Man, this is beautiful. I love this. Not in here, sorry. in the function. Sorry, that was terrible. Shifts amounts. Beautiful, beautiful, beautiful. And then we add this in here, and so we're gonna add the shift amount to be 1. Okay, and just like that, we're gonna have here 8, 5, 8, 5, 12, 12, and 15. So let's test this out. What happened? Can only concatenate string, not integer to string. Okay. Okay, because the character is being interesting. So character is being a string, and I want to convert it into an integer, so I'm just gonna go and do this and close the parentheses, and the shift amount is already a string, so this should function. Okay, but I don't know. No, it doesn't. Okay. It doesn't. Yeah. So here, but I cannot add string to integer. This is a little problem. Okay, hope this works. So yes, we are adding that character index, etc. Okay, you're looking for the position number first, but you have trapped the math inside the lookup function. Here's a breakdown of this error, and tries to turn H into a number. Yes, Python creates an error here because H it isn't a number. Okay, I understand. Because here we are actually looking for so this actually. Okay, interesting. I'm gonna call this interesting because it is interesting indeed. I'm gonna go and delete this, and I'm gonna add here a parenthesis. Beautiful. So my brother and my sister are gonna need to take this. So this is a number. This as a whole is a number. Sorry, I'm a noob. And just like that, it should work. Because this is a character H, and all of this transforms to a number. And this should work. Beautiful. That's what I'm talking about. Yeah. So this is done. We have shifted the indexes. What we need to do right now is to reverse it, to get from these beautiful indexes a characters from alphabet that correspond to these indexes. So I'm gonna go and function my head and say to my head, please do this. So this should function. Okay, this is very beautiful. I'm excited, so let's do it. We could do this. So we are adding numbers to our list as so, and we want to convert these numbers into this. Okay, so how to do this? What is the syntax that we need? Okay, so we have alphabet. So let's call the alphabet lists, and we are going to input the index. And yeah. Okay, hold on a second. Maybe I'm gonna need another for loop. Is that the case? Okay. Okay, I don't know. So let's remove this line because I'm not used to the syntax, but AI is used to, so it's gonna help us. So right now I have converted, okay, I have converted the indexes with the shift amount, and now I need the syntax to convert to actually grab the new characters from alphabets list and append them to the encrypted list. So let's see how this is gonna go. It's beautiful. I love it. I love it so much. So let's get it done. Okay, you are effectively doing the reverse for the first step now. Okay, beautiful. Step was give me a letter, get the number, use index. Okay, give me the number, get the letter. Okay, to get an item from a list using its number, you use square brackets. Beautiful. So putting it into your loop, you can wrap your math logic inside the square brackets to pull the letter out directly. So here we have the shifted position. Okay, we could use this alphabet char plus shifted amount. Use that position to grab the letter from the alphabet and shift. Okay, so this is a new letter. Okay, this connects to my head. Okay, we're gonna need another list. It's called encrypted text. It's gonna be an empty list, and I'm gonna go in here and use let me think about this. Okay, so we're gonna use encrypted text. Yes, we're gonna append and we're gonna use the index. Oh my god, is this AI smart? No, I'm not gonna do that. Okay. We could use another. Okay, that's way better. Rather than using a list, we could just use a variable called new position. Position actually. New position. It's gonna be equivalent to this, and then I'm gonna append this to the okay, rather than using this, I'm gonna use the brackets and new position. And let me okay, so let me make something like this with the just to test this. I'm gonna use positions, yes, dot append, yes, dot append. Come on, and like that. And I'm gonna paste this. We're gonna print positions. We are going to print new position. just for testing, so I could test this. And I'm going to print encrypted text, okay? So let's see this. And we are having 8, which is E, which is correct. And then here we are having F, which is, we see here, yes, it's correct. So this is functioning. So here we have as last the encrypted text, okay, which is a list that has all of these encrypted text that we need. And here we have the new position, okay, that's correct. So we have 8, 5, 12, 12, 15, and it translates to this. So that's crazy good. And positions, this is just to troubleshoot. Okay, so this functioning just good. Okay, so I'm gonna delete this, and I'm gonna delete this. I'm gonna delete this, and I'm gonna delete well, I guess this is enough. I'm just gonna go and print the encrypted text, okay? Yes, so we have EFMMP. We have H in here, and it's E, correct. And then for F, it is E in here. Then for L, we go in CL. Yes, L is M, successful, and O, where's O? It's B, okay. So this is actually working. This is actually active and it's working. So I could unlock this input. I'm gonna delete this one, and I could unlock the shift, and I could use the text in here, and I could change this integer to shift. Crazy good, that's good. And just like that, we are having a functional algorithm, cipher algorithm. Let's go. Let's clap on ourselves. So let's type our message. It's gonna be world, yes. And the shift is gonna be just 2 so that I could troubleshoot it if there is a problem. And there we go. Okay, so we have Y for world, so we see W in here. Let's look for W. And this is W, yes, that's correct. All of this is correct. So I need to do, which is to transfer this list into a variable with strings. So yeah, this AI that's integrated in here does the work for me. This is unbelievable. So it just takes this list and then returns it as a text. Okay, rather than a list, it's gonna be a text. So let's try this. World shift is gonna be 2. Oh my god, it didn't return anything. It didn't return anything. Why didn't you return anything, eh? Okay, we have here an error, etc. This AI, what this doesn't return anything. I could use print, which is basic. I just need to know why. Why? The encrypted text is not getting printed. Okay, paste this and see what's gonna happen. Okay. Oh, so we have to add the print statement rather than the return. And why? This is why the thing that I want to learn. I have 2 small issues here. One regarding indentation, where the code sits, and the one regarding output. the indentation issue. Okay, perfect. So the indentation issue, the loop stopper, and Python return is like an emergency exit. As soon as the computer sees return, it stops the function immediately and leaves. Because your whatever API. Do we have in here an API? What? We have here an API. This is crazy. We are having here an API. Is this a vulnerability? Please be. The page you were sent to. Oh my god. This is a true API or what? Real Python? Dot appends as item to your list. Oh my god. That was a real API. This might be a vulnerability. Interesting. I don't know why it didn't give me this URL. It gave me an API. Maybe this is a great sign for some vulnerability. Who knows? This shouldn't be like this. Okay. It seems like an URL, but it's using API as well, and who knows? Who knows? Maybe. So line is inserted inside the for loop. This happens. The loop picks the first letter H, calculates the new position, and hits return. The function stops instantly. It never looks at other ones. Okay. You must indent, move back the return lines so it lines up with the for statement. Okay. Let's see. Okay, let's remove this indentation. Maybe this would fix it. Okay, let's type our message. Hello. One and okay, so return doesn't work. It doesn't return the value that it should return, right? Which is weird. Okay, let's see. Return versus print. Currently, your function calculates the answer and hands it back. Returns it to the code that called it, but it doesn't. Maybe it does return that value, right? But we will need to add the print statement in here. So that function works like a function. It doesn't work like a print function. That's beautiful. Let's see if that works. Like, this is very interesting if it did. Yes, it works. Okay, so this function returns a value, and this value we could forward it to print, and this does the work. Beautiful. That's what I'm talking about, right? Okay. You could actually a lot of L's, a lot of C's. Okay, and that one here. Come on. You could actually add the print, or actually when calling the function, pass the function to the print function, and we could give him this line of code so he learns the stupidity that he's giving me, because that's how it's supposed to be explained, right? It returns the value, but this value is not printed. It just gets returned from that function, and that is cool. That is cool. So yes, exactly, that is a very professional way to handle it. If your function calculates the answer and returns it, you can pass the result directly into a print statement outside. But be careful, this method only works correctly if you fix the indentation error I mentioned. Okay, I fixed it, which is very interesting. What if I didn't fix it? What's gonna happen? So let's see. Oh yeah, there is a warning in here. There is a warning in here. Well, let's see what's happening. Let's type hello, indentation shift number is 1. Then we're having only E. What he said was true. So this function is fully functionable, and after we made encrypts, we're gonna make the other to-do list. So inside the encrypt function, shift each letter of the original text forward, etc. You can use the built-in Python index function to find out the position of an item in a list. Example, the fruits. Okay, so this one is number 1, etc. And this syntax, I didn't see it before. That's why my brain just stopped working. But yeah, this is very important to use this. Actually get that number, add it to the shift amount, and then you're gonna have a new position. And then you could append that to the encrypted text, and etc, etc. Which is very interesting, right? Yeah, it's very interesting. Love it. And the final encrypted output should be, here is the encoded results, AFMPP, right? That's true for hello, yeah. Each of the letter of hello is shifted by 1. Okay, so here to do 3. Call the encrypt function and pass it in the user inputs. Okay, so I'm gonna call that function encrypt. You should be able to test the code and encrypt a message. Okay, I did that. To do 4, what happens if you try to shift the letter Z forwards by 9? Can you fix the code? Oh, okay. Let's try that. Yeah, I'm going to forward Z, and the number is gonna be 9, and then we're gonna have an error. Lex in this out of range. Okay, how would you fix this? So there are many approaches to do this. One, you can add more than one set of the alphabet into the list of alphabet letters. Second, you can shift the shift amount so that it is always within 0 to 25 and it fits the list. You can use the modulo to get the remainder. Okay, interesting. So I'm gonna do my Google search, which is AI. So if I forwarded Z by 9, I get an error, which is out of range. Could you help me out with Python syntax to fix this issue? And I'm gonna give him here this. Okay, let's see what's gonna happen. He's thinking. Okay, we're waiting. We have used 2000 tokens, which is a lot. Okay, so we could use the modulo operator, which is recommended. You are exactly right about the index out of range error. You try to grab index 34, for example, from a list that only goes up to 25. Here's the syntax, hence the approach mentioned. Okay, so the modulo operator recommended. This is the mathematical way to handle the wrap up around in Python. The syntax for modulo find the remainder of a division in the percent sign. Okay, how it works: if you have 26 letters and your math adds up to 27, you want to wrap back to index 1. Okay, so 27 modulo 26. Results to 1. Okay, syntax, and you currently have position index plus shift. You need to wrap that math in parentheses and apply the modulo at the end. So I'm gonna have syntax calculation. So this is my calculation, and What is the total items? What do we mean by total items? Total items is the total number of the alphabet. Okay. Interesting. Okay. So I'm just gonna need to modulo 26. So we could wrap up from number 1 so that we loop through this mathematical algorithm. So let's get it done. Beautiful. So I'm gonna go here and input the modulo. Okay, so this is the modulo 26. So this should output me something that is correct, which is E. So where is Z? Z is here. If we made it by 9, if we added 9 to it, so it's gonna be A, B, C, D, E, F, G, H, E. Okay, that's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. So yeah, we have fixed the issue by modulo, which is very, very interesting. So this is done. I guess I should end this stream. I guess it's enough for today. And this is the final product, which is very interesting. So tomorrow we're gonna make the reverse, which is decode, and we're gonna wrap up everything in the 5th step, and we're gonna go and make the full functional program, which is our project. And yeah, by tomorrow we're gonna go and tackle more projects, etc. Or maybe we could do that today. Maybe. Let me think about it. Tomorrow or today? What about today? This is easy. This is very easy. So we're gonna copy everything in here and go to the next step. Okay, so we have her function that I don't really care about. Okay, so I'm gonna go and paste my stuff in here. Okay, beautiful. And I'm gonna go and copy all of these to-dos. And I'm gonna delete all of this. Okay, because I don't need it. I don't need it. And I'm going to replace this with the to-dos. So we have to do number 1. Create a function called decrypt that takes original text and shift amount as inputs. Okay, let's do that. So we are going to define decrypt exactly, and we are going to, inside the decrypt function, shift each letter of the original text backwards. So we're gonna go and use the same syntax, I guess. So encrypted text, okay, all of this is true. Original text list, etc. We're gonna make it into a list. We're gonna do a for character in original text. Oh my god, this is beautiful. This is beautiful. It does all the job for me. Oh my god, look at that. He made a minus signal. He made it for me. Oh my god. Oh my god, it happens. Magic. So yeah, that's the difference. We are going to minus that shift amount, and that's it. That's it. Okay, there is no more suggestions from the AI, but it's gonna be the same. So I'm gonna call this, rather than encrypted text, is gonna be called decrypted. So decrypted text, and I'm gonna go and I'm gonna add to the decrypted text in here decrypted text exactly. I'm gonna append to this list, which is decryption, the new position, and I am going to hold on a second. Yes, I'm gonna go and return this whole value that we are going to have, which is the decrypted value. Beautiful, beautiful, beautiful. So we're gonna return that, and the function seems to be beautiful. Okay, and we could print another one in here, the gcrypt. Yes, the G. Come on, hold on a second. Yes, the gcrypt, and yeah, that's it. What's happening here? Yeah. Okay, so this should theoretically function. So I'm going to comment out this function real quick. No, I'm going to use this function as a first. So yeah, so let's use it. So I'm going to type my message is gonna be hello, and I'm gonna type the shift is gonna be 1. Yeah, there is a problem here. Okay, I'm not gonna go and make that problem solved, because I'm just gonna take this text over here. I'm gonna copy it. I'm gonna run this function, which is decrypt. Then I'm gonna paste this text, and the shift is gonna be 1, and that's hello, and all of them are functional. So I could comment out this again, and I could copy all of this and go to the next step. So let's do it. So here we have a lot of to-dos. So yeah, we're gonna make so just gonna go in here and paste our work over there, and we're gonna see and analyze what's happening here. So import and print the logo from arts.py when the program starts. So at the fifth step, we are having another file in the same directory, so we could actually import it. So import art. Yes. Did we import let's ask AI if we did that, because I really don't do that frequently. I have another file of Python on the same directory, and I want to import it. Let's see. Maybe it's gonna give us the answer. Okay, from art, import logo. Okay, import the whole file. This requires you to type the file name every time you want to add something inside it. Okay, so this seems to be working. Will crash if you include if you include .py, is gonna crash. Let's try that out. Crash, motherfucker. Crash. Okay, no problem. Solved. Okay, so here we have imported, and then we're gonna need to print the logo. So print art dot logo. Yes. Okay, beautiful. So we're gonna go and print the logo, and then we have here the alphabet. What happens if the user enters a number, symbol, or space? Def Caesar, original text, shift amount, encode or decode. We have an output for letters in original text, F encode or decode, equivalent to decode, shift amount. It's gonna be a -1. Interesting. And shifted position. It's equivalent to alphabet.index letter plus shift amount. Shifted position, then the modulo. Then output text, so it's making the output text. Okay, here's the encode or decode the result output text. To do 3, you can figure out a way to restart the cipher program. Direction, etc. Okay. You can figure out a way to restart the cipher program. Okay, interesting. You could actually make a while loop or something like that. If it was yes, then we are going to execute that. If not, it's pretty easy. This to-do list 3. The second to-do list is pretty hard, but I'm going to use my functions, and for that I'm going to define a big function. But that's unnecessary because she already made this, which is pretty neat, isn't it? F blah blah blah. Okay. So this one is only for decode. If encode or decode equivalent to decode, then we're gonna do this. And then we are going to output that text. Otherwise we are we could make another if statement in here. Let me just copy this because I guess this is how it's gonna function. I'm gonna copy it and paste it. Yes, that's the if statement. If it was actually in code, then we are gonna do here a plus sign. That should fix everything. Beautiful. And then we are having 2 conditions, F and LF. Oh, problem. I guess we don't need to do an F statement in there, an LF statement. Okay, beautiful. So we are going to check that and see how it's gonna go. We are going to comment out all of this. This is gonna go and be a reference for us, but it's not necessary. And let's see what's gonna happen here. So this is the logo being what's twice? Why is it twice printed? It has been printed twice. Interesting. That's interesting. For some reason it's printed twice. I don't get it. Okay. So we are going to give encode and see if it does it work. Encode, and we're gonna type here hello, and the shift number is gonna be 1. Look at this. There's something wrong with her code, or my code. But no problem, I'm gonna fix that. No problem. Here is the code, and maybe we could use an MMMP. So maybe that's it. So H E E is gonna be an F. An F in here. H E and F. Okay. And L is gonna be M, and O is gonna be P. Okay, beautiful. That's my message. The shift is gonna be 1. Oh my god, what is this code? What is this code that she made? It's toxic. This code is toxic. I'm gonna remove all of this, but not actually all of this, but I'm gonna use for letter no, I'm gonna use this F statement because I like the F statement. It's the only thing that seems to be interesting in this whole piece of code. I'm gonna take it and I'm gonna delete all this unnecessary stuff that we don't need. Okay, so we're gonna delete all of that. Beautiful. And we are going to go and define our functions. We are going to uncomment them, and we are going to copy them. I'm going to delete this, and we are going to delete this as well. And we are going to copy the encrypt function, and we are going to define them in here. Okay, after that, I could technically copy this and paste it in here. See? Okay, so seems to be nice. Okay. And then I could copy this and paste it in here. Oh my god, what did I do? What did I do? So this is decode. Okay, so decode is the first one. So we're gonna go and grab our decrypt function and paste it in here. And for the encrypt function, we're gonna go and take this. Hold on a second. And we could technically paste it in here. And I'm gonna need to change some variables. I'm gonna copy these functions right now and just comment them out because I'm not gonna need them anymore. And we are having this variable that we are using, but we are having here the output text. So rather than encrypted or decrypted, we are going to okay, hold on a second. So this, rather than return, we're gonna use this variable. Okay, and it's gonna be equivalent, etc. So we're gonna assign this to the output text. Beautiful. It's gonna say to us this might be unassigned, etc. So it's a local variable, whatever. Okay, so this seems to be readable a little bit, at least functionable. So let's try it out. So we want to encode hello, and shift number is going to be 1. Yes, it's working like butter. And her code was actually false. My code is better. I'm going to decode EFMMP, and the shit is going to be 1, and it is hello. So it's working like butter, I'm telling you. So the third to do is to repeat the whole thing. It's going to be in here, very easy. It's going to be a while loop, and we're going to ask about we're going to make a repeat variable. It's going to be an input from the user, a prompt actually. So we're going to prompt to him. You see what the AI said about that? Type encode to encrypt, type decode to decrypt. No, that's not it. But I'm going to use a very similar mechanism. So okay, I'm just going to change this text. Okay, type yes, type yes, to play or to encode decode again, or type no to exit. Okay, and we're checking that to repeat, And with this function, I'm gonna do a while loop. So gonna be a while loop. If repeat yes is equivalent to yes, while this condition is true, then we could actually call this function. If this condition is not true anymore, we're gonna break this function. So let's try this out. So hello, type your message. Interesting. It's gonna get all these inputs. Actually, where should I? Okay. Man, I'm having all the ideas in the world. So we're gonna call this function first. Okay, we're not gonna care about his input. After the function has been executed, oh no, that doesn't go as well. That's problematic. That's indeed problematic. That's one function as well. Because the function is gonna exit before this again. I don't know. Let's try this out and see. Stop and return. Okay, let's see. Encode. Hello. 1. Okay. Oh, it's working just fine as it's supposed to be. Yes. Okay. I was just overthinking. Here's the encode result, EFMP, etc. So we're gonna just write. Oh no. This should be a small yes. Let's repeat this again so that we don't get any problems. Encode. The message is gonna be hello. The shift number is gonna be 1. And we're gonna type here yes. Oh my god, what's happening? We should reset. Actually, I understand what's happening. We should reset these inputs. So we're just gonna copy these and paste them. Direction, text, and shift, and this should do the work. Encode, message, hello, shift is 1. I want to continue. To G-code. Okay. The message is gonna be FMMP. The shift is gonna be 1. Say hello. They want to. Okay, that's interesting. So I'm not exiting this time, but we could ask for that in here. Ask for that in here as well. Okay, beautiful. Could delete all of this. It's unnecessary. Let's see if this functions. Okay, let's launch this. Where is the terminal? Can't see any terminal in here. Okay, beautiful. Here's the terminal. Encode. Message is gonna be hello. Shift is 1. Okay, yes, I want to repeat. I want to decode. I want to type the message to be actually I could delete this because it's unnecessary anymore. Okay, it's unnecessary, so it's just code repetition and we don't need it anymore. Okay, but here we're gonna have a problem. I don't care. Type your message, EFMMP. The shift number is gonna be 1. This hello. I want to exit, which is no. It functions like butter, but in here it exists within code because we don't know repeat, so that's the problem. Well, this is a way to do it, which is not optimal because we are repeating the same code. Don't do this. Ask AI to make it better. better. So yeah, for today I guess this is enough. For tomorrow I'm just gonna go and fix this issue in here. What happens if we enter a number, symbol or space? We need to catch these cases as well. That's another whole it's gonna take a lot of time because it's not easy to catch all of those cases. So yeah, till tomorrow. So that's it for this day. It was pretty hard work. So yeah, goodbye.